Today, I'm going to show you how to make a few of the most core systems from the popular arm wrestling games on Roblox. To give you a quick example, we have a couple of different NPCs here that we can fight. When we go up to one of them, we can go ahead and start the fight. We can see that a countdown is started, and once the countdown ends, we can begin clicking and actually start the arm wrestling challenge. If we do win, then we will see a little GUI pop up that says that we won, and that's pretty much all there is to it. Now, by saying that's all there is to it, I feel like that kind of diminishes actually how much it takes to create all of these different systems, so I don't want to undersell this at all because there is a lot that we're going to be creating today. Now, before we get further into the video, I have to give a huge shout out to one of my supporters who is known as Coastal. They're one of my supporters on Patreon and pretty much commissioned me to actually make this, and they were even kind enough to allow me to record a video on this and show all of you how to make the exact same thing. With that being said, if you would like to get direct access to the game and all the scripts that we create in today's video, there's a link down below in the description to both my Patreon or monster.dev, which is my own personal website, and you can support me on either of these platforms and gain access to all the scripts that we create in today's video, as well as a ton of additional assets which you can use to easily make your next Roblox game. Now, to easily get started with this, you're going to want to go down below in the description and it'll take you to this Roblox game called Module Framework. Keep in mind that this is a completely open source game, so you should see the 3 dots to the right of the game's name, and when you click this, it should give you the option to edit in Studio. So once we select Edit in Studio, it should put you directly inside of this game inside of Roblox Studio. To confirm that this is working, you should see something stored inside of the replicated storage, inside of the server script service, and inside of the starter player/starter player scripts. Now, if you're completely unfamiliar with the module framework, basically it's just a simple and easy way that I organize all of my projects. I'll leave a link down below in the description to a video where I explain the module framework, but if you just follow along with me, you should be able to have an easy time understanding this because it is pretty intuitive. Along with the module framework though, we also have a UI scalar local script inside of here, which we're not going to modify at all, but this script is going to easily and automatically scale all of our GUIs for every single device size, so we don't even have to worry about that at all. Anyways, now that we've opened up this game inside of Studio, let's go ahead and actually publish this place. The reason that we're publishing it is because it's basically as effective as saving your game so that we don't lose any progress. So we're going to go to the file button at the top left. The text highlighted here might be a little bit different than what you're seeing, but you're going to want to go to publish to Roblox or publish to Roblox as. Then I'm going to click on create a new game, and I'm going to go ahead and name my game Arm Wrestle Guide. I'm not going to set a description. The creator is going to be me. The genre doesn't really matter. And I'm going to disable team create because boy, do I not like team create. And once we've gone through all of that, let's go ahead and click on the create button. Cool. Now we can see that our game has successfully been published, so we're all good on that. All right, so now that we've covered all of our bases in Studio and we are all set up to start creating this project, the first thing that we're going to do is start off by creating all the aspects of the GUI. Now, if you're not a huge fan of GUI work, don't worry. There's not too much in the GUI that actually goes into this project, and it should be pretty easy to follow along with. The first thing I want us to do is actually change our Studio's screen resolution so that we're all beginning to create this GUI at the exact same device size. So to do this, we're going to go to the Test tab, and then in the Emulation section, we want to click on Device. And now that we've done that, we want to select the device that we want to emulate to, and inside of the Desktop section, I'm going to select HD 1080. And this will make a resolution 1920 by 1080. In addition to that, depending on how your screen size actually is, I would probably recommend you change the mode to fit to window. But if you want to do physical size or actual resolution and those things work for you, you certainly can choose any of those other options as well. That doesn't actually matter here, but I'm going to go with fit to window so that we can easily see the entire screen. So now that we've done that, let's actually go ahead and start creating the GUI. So inside of the starter GUI, we're going to go ahead and create a brand new screen GUI. We're going to rename the screen GUI to be called Match, and we want to make some changes to the property of the screen GUI. Really, the only thing that we want to change here is the ignore GUI inset option. We actually want to set that to true. The reason that we're enabling that option is because Roblox actually has its own sort of GUI towards the top of the screen. So we can see the little Roblox icon here, and we can even see the leader stats towards the right. And basically Roblox custom GUI, which I'll refer to as sort of the top bar, when ignore GUI inset is set to false, their top bar GUI will effectively push all of our GUIs a little bit further down. Whereas when the ignore GUI inset is set to true, the position of our GUI elements will pretty much no longer be affected by Roblox's own GUIs. So now that we have our screen GUI created, the next thing that we're going to do is add a frame inside of here. We're going to rename this frame to be called Click, and our plan for this frame is to basically turn it into a circle. And we're going to use this frame each time the player clicks or taps on the screen to sort of make a visual indication that the player has actually clicked or tapped. And I should mention that this will only be displayed to the player whenever they click or tap during an active match. So we can see the frame is currently a square at the top left of our screen. We're going to adjust the background transparency property and set that to 0.5 to make it a little bit see-through. Next, we're going to go ahead and adjust the sizing of this to make it a little bit smaller. And for the sizing of this, we are only going to be using offset. So for the size, we're going to go with 50 on both the X and the Y offset. Next, we're going to actually add a UI corner inside of this frame. And for the corner radius, we're actually going to be using scale here, and we're just going to set that to 1 and 0 on the offset. The reason that we're setting the corner radius to 1 is because when we do that, that actually turns our square frame directly into a circle. Now, it might be a little bit hard to see at the top left, so I changed my camera a little bit, and it should be a lot easier to see now. Now, realistically, the positioning of this doesn't actually matter. If you're having a hard time seeing it because it's at the top left, you could always put it in the center of the screen. But again, the positioning of this doesn't actually matter because as we're scripting this, we'll actually continuously be changing its position to wherever the player has tapped last. Anyways, now that we've done that, we're going to go ahead and set the visibility of this to false because we're actually done with creating that frame. Now, the next thing that we're going to do is inside of the Screen Gui, we are going to add a text label to this. We're going to rename this text label to be called status. And we actually do care about the positioning of this, and we want this to be centered on our screen. So for the anchor point, we're going to set both the X and the Y to 0.5, and then for the position on both the X and the Y scale, we are going to set that to 0.5 as well. And now that's centered in the middle of our screen. Next, let's go ahead and adjust the sizing of this. And we want to make this just a little bit wider. So on the X offset, we're going to set the size of this to 250. Next, let's go ahead and adjust the background transparency, and we're going to set that to 1. And now let's go ahead and modify the text. For the text of this, I'm going to say winner with an exclamation mark. And now I'm going to go ahead and adjust the text size. And we want to make it a little bit larger, and I'm going to go all the way up to the text size of 78. Now for the text color, I actually want to make this a green, so that's a specific green that I'm going with right there. And we would also like to adjust the font of this as well, and I'm going to go with the Ferdoka 1 font. Now we're almost finished with this text label. The next thing that we want to do though is add a UI stroke inside of here. And we're going to increase the thickness of the stroke to be 5. And that's all that we're actually going to do for the status text label. The status text label is going to be used at a couple of different times during our match. So for instance, when the match first starts up and there's a countdown, we're going to be using this text label for that, 3, 2, 1, and then it'll also display go. And when the player finishes their match, it'll also display the result of their match, depending on if they lost or if they won. So now that we're finished with that text label, let's go ahead and set the visibility of it to false so that we no longer see it for right now. Next, we're going to go ahead and add another frame inside of the Screen Gui, and this time we're actually not going to rename it. This frame is intended to be the progress bar, which is going to be towards the bottom middle of our screen, and it'll also display some other match information as well, such as our power and the opponent's power, and it'll also display the amount of times that we're clicking per second as well. So first things first, let's go ahead and resize this. Now for the X offset, we are going to set this to 1000. And for the Y offset, we're going to set that to 125. Next, let's go ahead and center this horizontally. So on the anchor point for the X, we're going to set that to 0.5. And for the position on the X scale, we're going to set that to 0.5 as well. And now we have that centered horizontally. Next, we want to bring this down towards the bottom of our screen. So for the Y of the anchor point, we're going to set that to 1. And for the Y scale of the position, we're also going to set that to 1 as well. Now we do want there to be a little bit of space between this frame and the bottom of our screen. So next we're going to adjust the Y offset of the position, and we're going to set that to -50. And now that we've set that to -50, we now have a little bit of space between this and the bottom of our screen. Next, let's go ahead and update the background color of this, and we're actually going to set that to a red. The reason for that is, again, this frame is going to sort of act as a progress bar. So inside of here, we'll also have another frame, which is going to be the green color, and that'll indicate how far the progress is to completing. This red basically represents the non-finished progress. Now, the next thing that we're going to do is add a UI stroke to this frame as well, but this stroke is going to be the exact same one that we used on the status text label, so let's just go ahead and copy and paste the one from our status text label into the frame. In order to do that, we're going to select this UI stroke and then hit Control-C, and then to put that directly inside of the frame, we're going to use Control-Shift and V to paste that into the frame. Awesome, and now that we've done that, we have a stroke around our frame. In addition to adding a stroke, we're also going to add a UI corner to this as well, because we want to make this frame a little bit round on both the left and the right side. For the corner radius, we're going to set this to 50, and we can see that this frame becomes a lot more round on the sides. Now, the next thing that we're going to do is actually create the progress frame inside of this frame. So let's go ahead and create a frame inside of here. We're going to rename this to be called progress. For the background color of this, we're going to go with a green. And now let's go ahead and adjust its sizing. Instead of using offset for this, we're actually going to use scale. So for the X scale, we're going to set that to 0.5. And for the Y scale, we're going to set that to 1 because we want it to stretch the entire height. But to kind of visually show this off to ourselves while we're working, we only want the progress to be about 50% completed. So that's why we're setting the X scale to 0.5 5 so that it's half the width of its parent frame. Now, when it comes to positioning, we have to do something that's a little bit less intuitive. The reason for that is because how these matches generally work is our player will be displayed on the right-hand side and the opponent will be displayed on the left. So rather than the usual progress of a progress bar going from the left side to the right side to be completed, this progress will actually start from the right side and go towards the left when more progress is made. So while it's not super intuitive, it's actually really easy to do. So for the anchor point on the X, we're going to set that to 1. Then for the position on the X scale, we're going to set that to 1 as well. Now, because we've just done that, you may have thought that this progress frame was actually going to begin at the very far right side of the parent frame, which it does do that, but you also probably thought because the size is 0.5 that it would extend to the right-hand side of the parent frame, but that's not actually what it does. Let's just go ahead and resize this horizontally. When the size of the progress frame is 0.1, that means that we're at 10%. You can now clearly see that when we resize this frame, it actually resizes towards the left rather than what, in my opinion, would be more intuitive and actually resize towards the right. So yeah, that's pretty much all that we have to do for the progress. I feel like there's more to explain here, but also at the same time, that's really all there is to it, and it works exactly how we want it to, and it's super easy to script. So I'm really happy with how this actually turned out, even if it's honestly the opposite of how I thought it would have worked. Now, there's still a few other things that we need to do to the progress frame itself. What we're actually going to do is copy the UI corner and the UI stroke from the parent frame and paste them directly inside of the progress frame. Now, if you wanted to, you could actually make a slight change to the UI corner. More specifically, the corner radius. Depending on how round you want this to appear, you can increase or decrease it. So if you wanted to, you could set this to like 30 and you can see how it appears here, which I kind of like that. Or you can leave it at 50 and it'll be the exact same amount as round as the parent frame. But with that being said, we are now done with the progress frame. Now, the next thing that we're going to do is actually create the text label, which displays the amount of times the player clicks per second. Now, to easily do this, what we're going to do is actually copy the status text label and paste that directly inside of the frame. And then we're going to rename this to be called title. We'll also make sure that the visibility is set to true so that we can actually see it. And then let's go ahead and play around with its positioning. Now, for the anchor point on the Y, we actually want that to be 0. And for the Y scale of the position, we also want that to be 0 as well. But of course, we don't want this to appear inside of the frame. We want this to appear a little bit above. So for the offset of the Y, we're actually going to set that to -75 to move this text label a little bit above the parent frame. Next, we can go ahead and actually adjust the text color, and we're going to set this back to the standard white. Next, let's go ahead and adjust the text size of this a little bit, and we're going to make this slightly smaller, and I'm going to set that to about 52. Then let's go ahead and actually update the text of this text label so that we can see what it'll look like. We're going to make this text label say start tapping ! And then in parentheses, we're going to say something like 5/S and then closing parenthesis. So that's what our text actually looks like. And we can clearly see that the text is out of bounds of its actual size. This doesn't actually matter unless you have something like the text wrapped property enabled or maybe another property, but we're not going to be using any of them here. If this does bother you though, then all you have to do is actually resize the text label a little bit. So it looks like 430 on the X should be enough to encapsulate this entire thing. Of course, then just make sure that you recenter it. But again, I don't think the sizing actually matters here. It should be perfectly fine without adjusting the sizing. And with all that being said, we're actually finished with creating the title text label. Now, the next thing that we're going to do is create the display for both ourselves and the opponent. And inside of this display, we basically want to display a headshot of our own character, and we also want to display a sort of headshot of the model of the opponent that we're going against. In addition to that, we also want to display the name and the power of both of us as well. So inside of our frame, we're going to add a new frame. First, we'll start off with creating the display for our own character. So we're going to rename this frame to be called self. Let's go ahead and adjust the sizing of this. So on the X offset, we're going to set that to 125. And for the Y, we're actually going to set the offset to 0. But for the Y scale, we're going to set that to 1 because we want it to stretch the entire height of the parent frame. Then let's go ahead and reposition this. And like I said, our own information will actually be starting on the right-hand side and our opponent will be displayed on the left side. So in order to display our own on the right side, for the X of the anchor point, we're going to set that to 1. And for the X scale of the position, we're going to set that to 1 as well. Now, because I don't want this to take up like 5 to 10% of the actual progress bar itself, what I'm going to do is adjust the X offset to about 20, and that'll just move this frame a little bit more towards the right. Because if we were just to move this frame, we can see that this frame is actually taking up a fair portion of the progress bar itself. So ultimately, you might even want to move this a little bit further, like 50 extra pixels. And even when we move it 50 extra pixels, we can still see that it's still taking up a decent amount of the progress bar itself, but you can kind of figure it out for yourself where you would like this frame to be positioned at. Anyways, the next thing that we want to do is once again, copy the UI corner and UI stroke of the parent frame and paste them directly inside of the self frame. Now we want to adjust the corner radius of the UI corner, and on the scale, we're actually going to set that to 1. And on the offset, we're going to set that to 0 because we want this to be a full-on circle. Now we can look at how this frame actually appears over top of our progress bar. And with that being said, I think we're now in a better spot to actually look and tell how we want to position this frame. While I went with 50 in the offset here, when I originally created this, I went with about 20. Just because when it's at 50, I feel like it appears a little bit too far to the right, and I'm not a big fan of that. But when it's at 20, I feel like it's positioned at a pretty nice spot, so I think I'm going to leave the offset at about 20 pixels. Anyways, the next thing that we want to do inside of this self frame is actually we're going to go ahead and copy and paste this title directly inside of here. Now, we're going to rename this title frame to be called player name. Now, for the text of this, we're going to say you, or of course, if you want to, you can display your own player name. But I'm going to say you because that's how other popular games have done it. And then we're going to adjust the text size as well. And I'm just going to bring this down about 10 pixels. So we're going to set that to 42. Then, of course, let's go ahead and position this properly. So we do already have it centered horizontally, but I think that we moved it up a little bit too much. So let's readjust this from -75 to -30 on the Y offset. And I think that looks a lot better. We can also readjust the sizing of it as well. So I think for the sizing, we can go with about 80 on the X offset. Again, the sizing of the text label doesn't really matter, but if you're like kind of OCD about it like myself, that's why I'm adjusting it. Anyway, let's make sure that we go ahead and recenter it horizontally, just like that. Now that we have that text label created and finished, let's go ahead and duplicate it. And now we're going to rename this to be called powered. For the text of this, we're going to say something like 999M. And now we want this to appear in the opposite to the player name. So we want this to actually appear at the bottom of the frame. So in order to do this, on the anchor point of the Y, we're going to set that to 1. And on the position for the Y scale, we're going to set that to 1 as well. Then, rather than subtracting 30 pixels from this, we're actually going to add 30 pixels to this. And there we go. That's nicely positioned towards the bottom of our frame. Then one of the last things that we need to do is add an image label inside of here, which we're going to rename to headshot. Now, you might be thinking like an FPS shooter headshot. What I actually mean by headshot is sort of the angle of a picture being taken. So the headshot is basically just a picture of our avatar's head from like a front-on view. Anyways, let's go ahead and resize this a little bit. We're just going to decrease the size of it a tiny bit. So on both the X and the Y offset, we're going to set those to 75. And then we want to center this in the middle of our frame. So for both the anchor points, we'll set that to 0.5. And for both the X and the Y scale on the position, we're going to set those to 0.5 as well. And for the background transparency, I don't think it really matters because our frame itself has a white background. So we don't need to adjust the transparency of this, but I'm going to go ahead and do it anyway. So we're going to set the background transparency to 1 so that we do not see any background. With all that being said, we are actually done with creating the self frame. So let's go ahead and duplicate this by hitting Control D. And now we can rename the new one to be called Opponent. With this one, we're going to go ahead and reposition this because we want this to appear towards the left-hand side of the progress bar. So for the anchor point, we'll set that to 0. And for the position on the X scale, we'll set that to 0 as well. Then for the offset of the X, we're actually going to set that to -20 because we want it to appear more towards the left rather than appearing towards the right. Now, going inside of this frame, we have the player name text label. Let's just go ahead and set a random name here just so that we can make sure that the size isn't too big. So we'll say Monster Dev. Now we can take a look at this text and you can see what you want to do with this. I would recommend that you test out the longest opponent name that you plan on having in your game, because once you type out the longest name, you can basically see the largest or the most expansive the text will ever actually get to, and then decide on how you want to size your text from there. So do you want to make it a tiny bit smaller? Are you okay with it being that large? Another option is actually using text truncate, which now the literal size of the text label matters here, because if you adjust the text truncate property to @end, what this will do is based on the actual size of the text label, it will basically cut off the remaining text and replace that with ... so that the text will not stretch out of bounds based on the size of the text label. So now if we were actually to adjust the text label horizontally, we can see that more letters are actually appearing. And of course, if we stretch it out long enough, then we can see the full word that we have set as the text here. So if we were to set the X offset to 200, that lets us fit in about 5 letters before it starts cutting off the rest. Of course, if you want to try to fit more inside of there, then you can adjust the text size property. But all of this is really preference, and it all depends on how you want it to actually be. For me, though, I'm not going to use text truncate. I'm just going to go with this sizing and this text size. But again, if you want to make any changes to this, you certainly have the options to do that. Now we're done with the player name text label. There's really only one major adjustment that we have to make inside of this frame itself. And instead of having an image label, we actually want to use a viewport frame. Now, the reason that we're using a viewport frame is because when we use a viewport frame, this allows us to actually display a headshot angle of our NPC model. Whereas when we're using an image label, we would actually need to use a literal picture, which should be a headshot of that model. And the reason that we're actually able to use this image for our self frame is because Roblox actually provides us with an API that allows us to get a headshot image of all Roblox players' characters. It's something that they automatically do, and it's sort of a way that your avatar is displayed on multiple places throughout the site and different things like that. So Roblox basically just has those images freely available for us to use. But when it comes to models, we would have to create our own individual images. So we would literally have to take a picture of every single one, then upload all those individual images to Roblox to be able to do it this way. Instead, though, we can just use a viewport frame, and then we can just use a camera inside of Roblox to basically recreate the headshot image, but this time with the real model that's directly inside of our game. Now, I'm sorry if that's confusing to you. It should be a lot easier to understand as we're going through and scripting this whole thing, but I did try my best to explain it as best as I could. Anyways, let's go ahead and readjust the sizing of this. So we'll set it to the same sizing that we had the image, so 75 and 75, and of course we want to center this, so 0.5 and 0.5 on both the scales. And again, we'll go ahead and adjust the background transparency, set that to 1 so that we don't see the background, and now that viewport frame is all good to go. And well, since we finished that, we're actually pretty much completely finished with creating this entire GUI. To really finish this off, let's go ahead and set the visibility of the frame to false so that we no longer see it. Of course, whenever the player starts up their match, we'll go ahead and toggle the visibility of this to be true so that they can see it, but for now, it does not need to be visible. Also, remember how earlier in the video I said that there is a UI scaler local script stored inside of the starter player scripts, which will automatically scale our GUIs for all device sizes? Well, because we have that, we have to do one more thing with this Screen Gui, and that's actually adding in a UI scale to this. Now, with this UI scale, we don't need to adjust any of its properties, but we do need to add a tag and an attribute. The tag that we want to add to this is actually called scale_component, so make sure you spell it just like that. And the attribute that we want to add to this is going to be called base_resolution, and the type is actually a vector2. So now that we've added the attribute to this instance, we also need to set the value of the vector2, and we're going to set that to 1920, 1080. And the reason that we're doing that is because when we created this GUI, we created it at a base resolution of 1920 by 1080. And the reason that we're adding this tag to it is because the UI scaler script actually uses the collection service, and it'll look for all the instances which contain this specific tag. And once it locates the UI scale which has that tag, it'll then handle automatically resizing and scaling all of the GUI for all different device sizes. Anyways, with all that being said, we are done with the GUI, so we can go ahead and collapse the starter GUI, and now it's just about time to start scripting. Now, when I start scripting in videos, I really don't like to be interrupted by adding different things or venturing off in different aspects. So before we begin scripting, let's go ahead and create the NPCs. Now, if you have your own NPC models, then you certainly can use them, but for us to easily just get some random NPC models that we can sort of use, we're going to go to the Avatar tab, and then we're going to select the Rig Builder. Now, this is actually a little bit hard to see while we're emulating our device, so I'm going to toggle that off so that we can actually easily see this. But from the Rig Builder, you can select pretty much anything that you want. I would recommend going with R15 just because that's what we're going to use in this tutorial. I don't think you'll need to make any changes for R6, but I haven't used R6, so I'm just not 100% sure. Anyways, though, you can select My Avatar if you want to import basically a copy of your own avatar. You could also import a skin avatar, which is that one right there, or really any of them that you want to. It doesn't really matter, but I'm going to go and use my own avatar like I just imported right there. Anyways, let's go ahead and reposition this a little bit. Now, inside of the workspace, I'm going to create a brand new folder, which is going to be called NPCs. Then I'll go ahead and drag that model inside of here. And now I'm going to rename this model to the name of what one of my NPCs would be. So I'm just going to rename this NPC to be called John. Now, inside of this model, we actually want to add a part to this. So inside of here, we should see a part, and we're going to rename this part to be called Table. Now that we've done that, let's go ahead and actually move this part in front of the model itself, and then we'll also drag it down a little bit. Now, if you're curious for my positioning, really the only one that matters for the most part is the Y, I would say. That's because we don't want the table to be up too high. I set that to 2.5. And of course, after we're done scripting this, you can kind of readjust this if you want to make any changes to it. Now, we did name this part table, and this is just going to be basically a placeholder since we're not actually using a table model. Another thing that we want to do is we want to make sure that this part is anchored. And well, actually, we want to make sure that every part of the model is anchored as well, so that none of them move or tip over or just fall apart when we start up our game. It's cool. So now that we've positioned the table and anchored the table as well as the model, we're pretty much done with this model. If you want to, you could duplicate it, then say move it over a little bit, and then say rename this to be another NPC. So our next NPC could be called Bob, for example. And then I'll go ahead and duplicate it one more time, and our last NPC is going to be named Tim. Cool. So now we have all of our NPCs laid out. Now we do have one more thing that we want to create, and that's actually just going to be a couple of different parts. And with these parts, we're going to attach proximity prompts to them. And these are basically just going to be for debugging and testing our system, because these proximity prompts, whenever they're triggered, they will increase the player's power by 1 or 5, or they'll decrease the player's power by -1 or -5. Now, the way I explain it might be a little bit confusing, but don't worry, you'll probably understand once we're done creating them. So we're going to create a brand new folder inside of the workspace, and we're going to rename this to be called power. Now, inside of here, we're going to want to go ahead and create a part. Then we're just going to go ahead and resize this a little bit. I mean, the size of it actually doesn't really matter at all, but we'll go ahead and move that right there. Then let's go ahead and rename this part to be called -10. I'm also going to delete the weld from inside of it just because it's something that I always do. I'm also going to anchor this as well so that it will not move. Then let's go ahead and duplicate it, move it over a little bit, and we'll go ahead and rename this one to be called -5. Then we'll go ahead and duplicate it again, move it over a little bit more. We'll rename this one to be called 5, duplicate it again, move it over a little bit, and rename this one to be called 10. And again, I'm going to delete all the welds just because it's personal preference. Now again, the reason that we're creating all of these is because we have a couple of different NPCs here who are going to have different amounts of power. So I want to be able to easily increase my power from, say, 0 all the way up to 50, then test with the first NPC, then I might want to increase it to like 100 or 200, test with the second one, and maybe I even want to decrease it to see how that has an effect as well. So these parts are going to be used to be able to easily increase or decrease your power by, say, 5 and 10. And with all those being created, we can now collapse that folder as well, and we're pretty much done inside of the workspace as well, so we can collapse that too. Alright, so now that we've got all those things set up, let's go ahead and start scripting. Now to begin scripting, the first thing that we're going to do is create the data service on the server side. The way that we're going to be managing our players' data in this game is going to be extremely simple, and really all we're going to be doing is creating a leader stat system, and inside of that leader stat system, we're going to include a single int value, which will be the individual's player's power. So in order to do this, we're going to go inside of the server script service, and inside of the services folder. Now inside of here, we already should have a data service and a skip service script. We're just going to go ahead and delete both of those. Again, those were just kind of both examples to show you how you could use the module framework. But anyways, the next thing we're going to do is go ahead and create a brand new module script inside of here, which we're going to rename to be called data service. Now, inside of this module script, we already have a module variable created for us. What we're going to do is we're actually going to rename this variable to be called shared instead of module. And then above the shared variable, we're also going to create a variable called local, and we're going to set that equal to a table as well. Now, let's go ahead and create our function for setting up the player's data. Since this function is only going to be used inside of this single script, we're going to add this to the local table instead of the shared one. So we're going to say local dot, and then the name of this function, which is going to be setUpPlayer, and that's going to accept a player, which is of course a player. Now again, what do we want to do inside of this function? Well, we want to create the leader stats for the player. So we're going to create a variable called leaderstats, which is going to be equal to instance.new, and the leader stats, of course, is a folder. And where do we want to parent this to? Well, we want to parent it to the player. Then we have to rename this folder so that we can actually make it into the leader stats. And what are we going to rename it to? Well, of course, we're going to rename it to leader stats, if I can actually spell that correctly. Now that we've created the leader stats folder, we then have to add some sort of value to this. And the value that we're going to be adding is for the player's power, which of course will be an int or number value. You can use either int or number value, it doesn't really matter here, but we're going to go ahead and say local power equals instance.new, and we'll go ahead and create an int value and parent that to the leader stats folder. Then let's go ahead and rename this to be called power, and let's set the player's default power to 5. Cool, so now we finished creating the setUpPlayer function, which will create the leader stats for our players, but now we have to actually use this function. And when do we want to use this function? Well, we want to use this function for whenever a player joins our game. So what does that mean? Well, we have to go ahead and create a variable for the player service. So we're going to say game, get service, and then we're going to get the player service. Now, the usual way of connecting events to functions would be by adding them to the bottom of the script. So we would say players.playersadded, connect, and then we would go ahead and connect it to the setUpPlayer function, which you can do that here, but there is a little bit of a nicer way to do this in my opinion, because we are using the specific module framework. So what I would actually do is create a brand new function, which is going to be attached to the shared table, and this function is going to be called onStart. And rather than putting this line of code at the bottom of our script, we're going to go ahead and put it inside of this function. Now, the reason that we're doing this is because the way that this framework actually works is because when the framework actually requires all of these module scripts, so all of the services and controllers, if they have an onStart function attached to them, then that function will also be executed as well. So that allows us to have an onStart function towards the top of our script, and it really allows us to intuitively identify where things are actually happening at. In my opinion, it feels a lot more intuitive to sort of connect these events inside of an onStart function, which would be the first function inside of our script, rather than adding these these things at the very bottom of our script, which would be like the last thing that you possibly see in this script. Imagine if our script was a lot longer and we had to scroll super far down to actually see, oh, I forgot, we connect these events all the way down here. So instead of that, all I have to do is look at the first function that's inside of the script and I can see it right here. This is where I connect all of my events to different functions and do everything like that. Anyways, there's another time that we actually want to call the setup player function, and that is when this script first loads up, or really whenever the onStart function is called. We want to actually loop through all of the players that are currently inside of the game. And for the most part, this really only happens when you're playing in studio. Usually when a player joins your game, they will not load in before the server scripts load in for the most part, but it's not always guaranteed. So we're going to say for underscore player in players, get players do. So we're going to loop through all the players who are currently in our game when the onStart function is called, and we're going to go ahead and make sure to set them up. So we're going to say setup player, and then we're going to pass through the player. And now that we've done that, the player will always be set up. So whether they were already in the game before the script loaded, or whether they get added because the player added event is fired off when they first join the game. So now we should actually be able to go into our game, start it up, and test this out. Now you may see some errors in the output. That mostly stems from the example controllers that we included on the client side because we just haven't deleted them yet. But aside from that, you should actually see some leader stats appear, and although it might be hard to actually see on my screen because it's a lot smaller, we can clearly see that I do have the power leader stats and I have 5 power right now. So we know that that's working correctly. Now that we've gotten the player's leader stats set up, let's go ahead and actually set up these power blocks that we added earlier so that we can easily increase and decrease our power for debugging. Now normally I wouldn't do this inside of the data server script. I would only keep information in here relevant to actually the player's data. But since this is a smaller project, there's really no point in me separating this into another script because it's only one function that we're even going to create. So that's why I'm going to create it directly inside of here. So we're going to go ahead and create another function. This function is only going to be used once by this script. So this is going to be added to the local table. And this function is going to be called setup prompts. And it's not going to have a single parameter. Now inside of this function, what we want to do is we want to loop through all of those parts inside of the power folder inside of the workspace. So we're going to say for underscore part in workspace. Now, you could just use the normal workspace, but let me go ahead and create a variable for the workspace service. So we'll say workspace and workspace. Okay, now that we have the workspace service, we're going to say workspace dot, then get the power folder, and then we're going to say get children. So each time this loop iterates, we're going to be going through each of the parts inside of the power folder. And remember, the name of these parts are numbers. So -10, -5, 5, and 10. So we're going to create a variable called power amount. And how do we get the power amount? Well, that's going to be from its name. So we're actually going to say to number because the name of a part is a string. So we have to convert that string into a number. And what are we going to convert into a number? Well, the part's name. So we're going to say part.name. Now that we've gotten the power amount, the next thing that we want to do is actually create a proximity prompt. So we're going to say local prompt equals instance.new, create a brand new proximity prompt, and we're actually going to parent this proximity prompt to the part. Then let's go ahead and set the action text of this prompt, and we're going to say adjust power by, and then we'll actually display the amount of power that we're going to adjust the player's power by. Of the prompt, we also want to adjust the requires line of sight property, and we want to set that to false, because we don't want to have to do too much to actually position this prompt. We just want to be able to quickly and easily throw this into our game to be able to just test this out and debug it. So we're setting requires line of sight to false because we don't care about the positioning of this prompt. We just want to be able to get close to these parts, and whenever we get close to these parts, we can see the prompt and activate it. Then finally, we actually have to listen for the prompt to be triggered. So we're going to say prompt.triggered, connect, and we're going to create an anonymous function inside of here, which is going to give us the player who triggered this prompt. And whenever a prompt is triggered, what are we going to do? Well, we're going to adjust their power. So we're going to say player.leaderstats.power.value. And now we're going to say plus equals, and then the power amount. So now, each time the player triggers the prompt, their power will either increase or decrease based on whichever one they actually triggered. And that's all that we have to do for this function. So when are we going to use this function? Well, let's go back to the onStart function, and that's actually the first thing that we're going to do inside of this function. I'm going to say local.setupPrompts and go ahead and call that function. So now, to test this out, whenever I go into my game and I actually go over to these blocks, we can see adjust power by 10, adjust power by 5, adjust by -5, and -10. And let's go ahead and activate these. Now, when I activated that, my power went from 5 to -5 because I activated the adjust power by -10. Let's go ahead and adjust our power by 10, and we can see it now goes back to 5. Then if I click it again, we're at 15, then 25. So we can clearly see that these are all working perfectly. Now, before we get into scripting the next part, I want to go ahead and add in the networking so that we don't have to take a break in the middle of scripting and add this as we're doing it. To create the networking, we're going to go inside of the replicated storage, and we're going to create a brand new folder. This folder is going to be called remotes, and inside of here is where we're going to add some remote events. The first remote event that we're going to create is going to be called tap. Then we'll go ahead and duplicate this by hitting Control and D. The next remote event that we're going to create is going to be called match start. Of course, we'll duplicate this again. Instead of match start this time, the next remote will be match end. We'll duplicate this again. Instead of match end, this will be match progress. Duplicate it once again, and this one will be called match countdown. So in total, you should have 5 remote events. Now that we've created all those remote events and we're still inside of the replicated storage, let's go ahead and actually create our opponent's config. So inside of the replicated storage, we're going to create a brand new folder. This folder is going to be called configs, and inside of here, we're going to add a brand new module script. We're going to rename this module script to be called opponents, and now inside of this module, we are going to once again rename the module variable from being called module to being called shared. Then we're going to create a table and add that to the shared table itself. So we're going to say shared, and the table is going to be called config. So we're going to say shared.config equals a table. And now inside of this table, for the keys, we are going to be using our NPCs names. So remember, when I created my NPCs, the names I went with were Bob, John, and Tim. Then for the values of those names, we're going to have a table, and inside of that table, we're going to have some information about the specific NPCs. For instance, the amount of power that they have. So we'll start this off with our first NPC called John. So I'm going to say John equals, and again, for the value, it's going to be a table. And now inside of this table is where we're going to store some information about John. Currently, the only information we're going to store about John is how powerful he actually is. So John only will have 10 power because he'll be the first opponent. Then we're going to add another NPC. So we're going to put a comma after John's table, and then we're going to go ahead and add the Tim NPC. Now Tim is going to have power as well, but Tim is a little bit stronger, so he's going to have 100 power. And then finally, we'll go ahead and add Bob, who again is going to have power, and oh boy, he's going to be a lot more powerful than both of them. And he's going to have 1,000 power. And since we're only starting off with 3 opponents, we're actually done with creating that config table, at least for right now. Now, the last thing that we want to do inside of here is actually create a shared function. And this function is going to be used to calculate the total health of a match. Now, once we create the function, I'll explain exactly what I mean, but I think it's a little bit easier to understand when we can actually take a look at the function itself. So we're going to say function, and again, this is going to be a part of the shared table, and this function is going to be called getMaxMatchHealth. And it's only going to have a single parameter, which is actually going to be a string, and that would be the opponent's name. Now, the first thing that we want to do inside of this function is we want to get the information about the specific opponent. So we would call this the opponent config. So I'm going to say local opponent config equals, and then we're going to say shared.config and index that table with the opponent's name. Then we're going to create a variable for the opponent's power, and that's going to be equal to opponent config.power. Then to determine the max health, we're going to return power times 10. Okay, I added some notes to my script to make it easier to understand how matches will actually work, so that it becomes more apparent to us why we are calculating the max match health this way. So let's go ahead and set up an imaginary match. The opponent has 10 power and we have 5 power. Now, opponents are going to tap 2 times every single second. So if the opponent has 10 power and they can tap 2 times, then that means that every single second, the match will be losing 20 health. Now, us as players can actually tap up to 5 times per second. So if we have 5 power and we can click 5 times per second, then that means at our max, we would be adding plus 25 health to the match every single second. Now, this isn't really important, but it is technical, and I don't want to confuse anybody. In reality, we wouldn't actually be adding plus 25 per second at our max, because we also have to account for how much the opponent is subtracting as well. So in reality, at our max, we would be able to add plus 5 per second, because minus 20 plus 25 would be only 5. But this part isn't exactly important. I just want to clear up any confusion. Now, keep in mind that the match's max health is actually 100. So by max health, we're referring to the number that the player needs to reach to actually win the match. And why is the max match health 100? Well, because the opponent has 10 power. And how are we calculating the max match health? Well, we're multiplying their power by 10. Now, keep in mind that the match ends at either 0 or 100. So it ends at either the max health or 0. If it ends at 0, that means that the player lost. And if it ends at max health, then that means that the player won. And another important thing is when the match begins, it starts at half health. So in this match, for example, it would start at 50 because 100 divided by 2 is 50. Now you might be wondering, why are we doing matches this way? The reason that we're running matches this way is because we want matches to be able to scale with every single power level. Now, I'm not sure as to how well of a job I did at trying to get you to understand this, so I don't want to go into like 2 or 3 more minutes of actually re-explaining this to get you to understand it. If you're having troubles understanding it, I feel like once we actually develop the system and you can visually see exactly what we're doing, that might be the most helpful thing I can do to make you understand it. So that's what we're going to try to do. So with that being said, we are done with the opponent's config. We can go ahead and close out of that. And we are done with the data service as well, so we could close out of that script if you haven't done that already. And the next thing that we're going to do is start scripting the match service on the server side. So inside of the services folder, we're going to create a brand new module script, and we're going to rename this to be called match service. Of course, the module variable is going to be renamed from module to shared, and we'll go ahead and create the logo table inside of here as well. Now, towards the top of our script, we're going to want to go ahead and create some variables for different services that we'll be using. First, we'll create a variable for the player service, so game get service players, and we'll create a variable for the replicated storage as well. Now that we've created those variables, we also want to create a variable for the opponent's config that we just created. So we're going to say opponent's config equals require replicated storage dot configs dot opponents. And we also want to create a variable for the remotes folder that we created earlier as well, which is also inside of the replicated storage. Now that we've gotten all those variables that we're going to be using in just a little bit, what we're going to do is start off by creating a type. The reason that we're creating a type is because when we actually use types and do these things, it makes it a lot easier for us to understand our code, especially if we come back later on and we might not have remembered exactly how we're doing everything. So the type that we're going to create is going to be called match. Now, we're going to use this type as a way of storing the data for whenever a player enters into a match. There's 2 things that we want to store about that match, and that is the opponent that the player is going against, as well as the current score of the match. So we're going to say opponent, which is going to be a string, and then we're going to say score, which is going to be a number. Now, when are we going to use this type? Well, we're going to create a variable called matches, which will be used to store all of the match data for every player whenever they go into a match. And let's go ahead and actually set the type of this variable. So let's go ahead and use a colon. Now again, this variable is going to be a table. Now the keys inside of this table are actually going to be numbers, and more specifically, those numbers will be the player's user ID. Now the value attached to the player's user ID is going to be the match type that we created earlier. So now that we've set the type of this variable, we're going to set that equal to a table. So to reiterate, the matches variable is going to be a table, and this table is more specifically going to be a dictionary. So the keys of this dictionary are going to be the player's user ID, and whenever a player enters a match, we're going to add them to this variable. And the data that we're going to store, which is going to be attached to that user ID, is going to be the opponent that they're going against, as well as the current score of the match so that we can keep track of that. So that should be pretty easy to wrap your head around. In addition to that though, we are going to create another variable, which is actually going to be called tap cooldowns. The reason that we're creating this variable is because we want to limit the amount of times that players are able to click per second. And keep in mind, as we're progressing through this video, I'm going to be using the words tap and click synonymously. So anytime you hear me say click or tap, pretty much assume that they mean the exact same thing. Now we can also set the type of this table as well, which is going to be very similar to the type of our matches variable. So the keys that are going to be stored inside of here are going to be the player's user ID, and the value is going to be a number as well, which is actually going to be the last time that that player has tapped. So now that we've set the type of that, we are going to set that equal to a table. Then we're going to go ahead and create a constant variable. Now, constant variables are typed out in all capital letters. They're not really any different from a normal variable, but what we mean by a constant variable is this variable will never change. These variables are nice to make because when we look at our script, we can easily see them, and then we can say, oh, that's probably just a quick variable that I have to modify to change how a specific system in our game works. So this variable is going to be called max taps per second. So we're going to say max underscore taps underscore per underscore second, and we're going to set that equal to 10. So we want the player to be able to click a maximum of 10 times per second. Cool. So now that we've created all those prerequisite variables, we can go ahead and start writing the logic by creating some functions. So we're going to go ahead and create a function. This is going to be a part of the shared table. This function is going to be called start match. It's going to accept a player, of course, which is a player, and it's going to accept an opponent, which is going to be a string. Now, inside of this function, before we actually start the match for a player, what we want to do is check if they are already in a match. Because if the player is already in a match, then they shouldn't be able to start another one. So we're going to create a variable called isInMatch. And to determine if a player is already in a match, all we have to do is index our matches table with the player's user ID. And if we're able to find the player inside of that table, then we know that they are actually actually inside of a match. So if the player is in a match, then we're going to return end to stop the function right there. Now, if the player is not in a match, then we know that we can actually add them to a match. So since we know this, the first thing that we need to do before we start their match is determine the maximum health of the match. And how can we do that? Well, by using that function that we created earlier inside of the opponent's config. So we're going to create a variable called total match health, which is going to be equal to opponent's config.get max match health. And we're going to pass through the opponent. Now we've gotten the total match health, the next thing that we're going to do is go ahead and create a table called match. And inside of here is where we're going to add all of the information about the specific match. And actually, to make this easier on ourselves, we can even set this variable to the match type that we created earlier. So inside of here, what do we want to store? Well, we want to store the opponent. And who is the opponent? Well, of course, that is the opponent variable, which is passed to this function. In addition to that, we also need to specify the score. Now, since we're just starting the match right now, remember what I said earlier. The match is going to start off with basically 50% health or progress. So we're going to divide total match health by 2. And that'll allow us to start off about halfway. So now that we've almost created the match itself, the next thing that we want to do is actually fire off a remote event. And this is going to be the match countdown remote event. So we're going to call fire client on that, and we're going to fire that to the specific player. Now we're going to pass some information along with this though, and we're going to include the opponent as well as the current score. Now the reason that we're firing this event off is because we want to tell the player, hey, a match is about to start. So go ahead and start the countdown GUI, visually showing the client, hey, we're about to start a match, get ready, 3, 2, 1, and then go sort of a thing. So since we're firing off the match countdown remote event, that doesn't mean that we've even started the match yet. We still have to do that, but we're actually going to use task.delay here, and we're going to wait 3 seconds before we actually begin the match. So after 3 seconds, once the countdown has actually finished, we're going to go ahead and officially start the match. And in order to do that, what we're going to do is add this match information to the matches table that we created earlier. So we're going to say matches, then we're going to index that with the player's user ID, and we're going to set that equal to the match information that we just created inside of here. And now that we've done that, we've really basically started the actual match itself. So the next thing that we want to do is communicate this to the client. And we're going to do that by using a remote event. So we're going to say remotes.matchStart::fire client, and we're going to fire that to the player. So now, with all of that being said, we are done with creating the start match function. Next, let's actually script the logic for whenever the player taps. And keep in mind that we're going to be using a remote event on the client side whenever the player taps to communicate that to the server. So we're going to say function, and we're actually going to add this to the local table, and this function is going to be called onTap. And the only parameter that we're going to go with here is the player parameter. Now, first things first, we want to make sure that the player is actually inside of the match. So we're going to say local match equals, and we're going to try to find their match. How do we find their match? Well, we index the matches table with the player's user ID. And if we're not able to find the player's match, then they're not actually in a match. So we don't care about them tapping. So we're going to return and stop the function right there. Now, the way that I explained the tap cooldown earlier was actually slightly incorrect, and I do apologize for that. The way that tap cooldown is actually going to work is we're still going to be using the player's user ID as a key. But instead of the value being the last time that the player has clicked, the value will actually be the amount of times that the player has clicked in the last second. And we're going to use this to prevent the player from going over the max amount of clicks per second. Now, while that might be confusing, it's actually super simple and straightforward, so just follow along and you should easily understand it once we get finished creating this function. So we're going to create a variable called taps in last second. So we want to determine the amount of times that the player has clicked in the last second. And the way that we're going to do that is by using the taps cooldown table and indexing that with the player's user ID. Now, if the player is not inside of this table, then we're just going to assume that they have not clicked at all. So we're going to say or 0. Next, we're going to create a variable for determining if the amount of taps that they've had in the last second is greater than or equal to the max amount of taps that we want to allow them to tap per second. So this variable is going to be called is more than max taps, and that's going to be equal to the taps in last second is greater than or equal to the max taps per second. Now, if that variable is true, so if there is more than max taps, then we're going to stop the function right there because we want to prevent the player from clicking more than the max taps that we allow them to. Now, if we're able to make it this far down in the function, then we know that they've not passed this limit. So let's go ahead and allow their tap to actually count. And since we're allowing it to count, we need to add this to their cooldown. So we're going to say tap cooldowns, index that with the player's user ID, and we're going to set that equal to the taps in last second plus 1. And since we're limiting this per second, we want to wait 1 second, and then we want to remove that tap from the cooldown. So we're going to say task.delay 1, then we'll create an anonymous function, and after waiting 1 second is when we want to reduce the tap cooldowns by 1. But now we actually have to watch out for an edge case here, because what if a player has actually disconnected before this task.delay has even fired? Well, that means that we want to check the tap cooldowns table once again to make sure that the player is still inside of there. And as long as the player is still inside of there, what we're then going to do is say taps cooldown, index that with the player's user ID, and we're just going to go ahead and subtract 1 from that value. Cool, so now we're all done handling the cooldown and making sure that the player does not go over the tap limit. The next thing that we want to do is determine how much power the player actually has. And we can do this by using the player's leader stats. So we're going to say player.leaderstats.power.value. And now that we know how much power the player actually has, every single time they tap or click, we want to add the amount of power that they have to the score of the match. So we're going to say match.score plus equals the player's power. Now you might be wondering, why is this underlined in red? Is that wrong? Is this an error? And the reason for that is because Roblox Studio does not actually know that the player object has the leader stats attached to it. Now, what I just wrote up here is like the safest method to actually do this. So we would create a variable called leader stats. Inside of the player object, we would use find first child to look for something called leader stats. And now I'm using 2 semicolons here to actually be able to direct Roblox Studio as to what type this variable should actually be. So I'm saying that this variable should actually be a folder. Then I'm saying if there is no leader set, so if this is not found, then we would want to stop the function right here, which is true. We would want to do that. Then we're creating a variable called power, and we're looking inside of that leader stats folder, trying to find something called power. And again, I'm using these double semicolons to tell Studio that if we do find it, it would be an int value. Then again, we're saying if power does not exist, so if we don't actually find this instance, then return end and stop the function right there. And then we would go ahead and update this variable right here and say power.value, just like that. And now we've erased all of those underlines. But like also at the same time, this was all kind of just unnecessary because realistically, this is not an issue that you should ever actually encounter unless you like really messed your game up. But yeah, the method that I just show you is like the safest one and it'll prevent this red underline and stuff like that. But also at the end of the day, I feel like there's less than a 1% chance of you actually encountering an error or an issue from how this is set up. In my opinion, the worst thing about it is that it's just underlined in red, and that is the most annoyingest part about it. Anyways, with all that being said, we are done with creating the onTap function. So let's go ahead and actually set up when this would be used. So towards the top of our script, we're going to go ahead and create that onStart function that we normally do. So we're going to say function shared.onStart. It's not going to have any parameters. And what do we want to do inside of this function? Well, we actually want to listen for that one remote event to be fired, the tap remote event. So we're going to say .onServer event, and we're going to connect that to the local .onTap function. So whenever the client communicates to the server, hey, we just tapped, the onTap function is going to run. It's going to check if they're inside of a match. Then it's going to check if we should actually count this tap or if they've passed the limit of clicks per second, and then it'll run through the actual tap logic. Now, before we actually script the match logic itself, let's go ahead and create another function, which is going to be called stop match, and this is going to be attached to the local table. The only parameter here is going to be the player parameter. Now, when this function is called, first of all, we want to check if a match was actually in progress. So we're going to go ahead and create a variable called match, which is going to be equal to matches, and index that with the player's user ID. Now, if there was no match in progress, then we want to stop the function right there. After that, though, we want to create a variable for the score of the match. So we're going to say match.score. Now, in addition to getting the score, we also want to get the max match health. So we're going to create a variable called max match health, which is going to be equal to the opponent's config.get max match health, and then we're going to pass through the match.opponent, so the opponent of that match. Now that we've gotten the score and the max match health, we can actually determine if the player has won the match or not. So we're going to create a variable called didWin, which is going to be equal to the score being greater than or equal to the max match health. Now that we've determined if the player has won or not, you might want to do some different things on the server side, like probably reward the player some currency or do different things like that. But obviously, since I'm not turning this into a full game, I'm not going to add the currency here because we don't even really have a real data system set up. This is all just to kind of show you how I would do it. But what we are going to do is actually fire off the match ended remote event, or more specifically, match end. So we're going to go ahead and fire client. We'll fire it to that specific player. And we're also going to tell them if they have won or not. And now that we've communicated that information to the client, we can go ahead and clear all of the match data. So we're going to say matches, index that with the player's user ID, and we're going to set that to nil to clear that match out of that table. We also want to clear the player's tap cooldowns as well. So we're going to say tap cooldowns, index that with the player's user ID, and set that equal to nil. So now we've basically cleaned up the match since the match has finished. And that's actually all that we have to do inside of this function. Now currently, there is actually one time when we can call this function, and that is when the player is leaving our game. So we're going to say players.player removing, and we're going to connect this event to the stop match function that we just created. We want to do this because if the player leaves our game, we want to make sure that we clean their data up from the tables that we were using, because if we don't clean that up, then eventually we're going to have a memory leak, and it could drastically negatively impact the performance after a long time of building up from a bunch of different players. Okay. Now, the last thing that we're going to do inside of here is actually script the match logic itself. So we're going to create a brand new function, which is going to be attached to the local table. This function is going to be called match loop, and it's not going to have a single parameter. Now, what we want to do inside of here is we actually want to create a while true loop. Now, a while true loop basically just means that this will run forever. The next thing that we want to do is we actually want to use a p call. The reason that we're using a p call is because normally without the p call, if an error happens inside of this while loop, that will force the while loop to stop. But if we use a p call, then if there is any errors inside of here because something just went wrong, that will allow the while loop to continuously run as we intend for it to do. It will not completely cancel out the while loop. Now, this is incredibly important because there is a chance that there is an error that comes up in our match logic. Like, let's just say that we didn't account for every single edge case in our game. Maybe the player leaves the game at a very weird time and that causes an error to occur inside of here. If that error occurs inside of here, again, without the p call, that would break the entire loop and literally stop all of the match loop logic for the entire game, meaning that the game would effectively be ruined for every single player who joins the specific server when the error occurred and broke the game during that time. So like that whole server would be entirely broken until all the players left and then the server ended and like restarted basically. So that's why the p call comes in handy here, because this is vital logic. If this while loop stops, then our entire game basically stops as well. But since we're using the p call, if we have any errors inside of here, the while loop will just continuously run. And even if it like runs and runs and runs and it keeps encountering an error, that's okay. One player's game might just be bugged out and maybe that person might just have an issue with the game, but that won't prevent every single other player from continuing to play the game in that same server as well. Now that we understand why we're using the p call, after the p call, we also want to add a task.wait. So we're using this to be able to limit the amount of times that the while loop will iterate, and we're going to set the task.wait to 0.5. That means that this while loop will run 2 times per second. So going back inside of the p call, where we're going to put all of the logic for the match loop, what we first want to do is loop through all of the matches which are currently going on. So we're going to say for user ID, comma match in matches do. Then as we're iterating through all the matches, the first thing that we want to do is actually get the player object from the user ID. So we're going to create a variable called player, and to be able to get the player object from their user ID, we can use the player service. So we're going to say players, get player by user ID, and then we're going to pass through their user ID. Now, if we're not able to find that player, then we want to stop the function right there, but we don't want to say return, because if we say return, that will cancel out this while loop as well. Instead, we want to say then continue end. So we want to continue through the loop and iterate to the next match. So now that we've gotten the player, the next thing that we want to do is create a variable for the opponent's config. So we're going to say opponent config, which is going to be equal to opponent's config.config, and then we're going to index that with the actual opponent's name, so match.opponent. Now that we've gotten the opponent's config, we can create a variable for the opponent's power, which is going to be equal to opponent config.power. So now that we've gotten the opponent's power, we can actually start modifying the match score. So we're going to say match score minus equals, and then we're going to say opponent power, but we're going to divide the opponent's power by 2. The reason that we're dividing it by 2 is because, remember, this while loop will iterate 2 times every single second. An alternative to what we could do, we could have this while loop run 1 time per second, and then we wouldn't need to divide the opponent's power by 2. We could just have it subtract all of the opponent's power each second. But the reason that we're having it run twice per second, and we're doing it this way, is because it actually makes the match feel a little bit more real. Like, for instance, if the match progress was only updated once every single second, it wouldn't really feel like that natural. But now that we're updating it twice per second, it feels a lot more real, even though this is all like kind of just completely fake. If you're having a hard time understanding what I mean by that, at the end of this, you could just change the task.wait to 1, and then you can see how it feels. Updating the match progress every second, it just does not feel good at all, in my opinion. After we modify the match score, we then want to communicate that to the client. So we are going to use a remote event for that. and we're going to go ahead and fire off the match progress remote event. So we're going to say fire client, we're going to pass through the player, and then we're going to tell them the updated match score. Now, if you're like me, you might be thinking, oh, why are you firing off this remote event? Why are you communicating them the match score? Like, couldn't we just calculate this stuff on the client? And yes, we could calculate it on the client. You totally can do that. But I also like to have these remote events which fire off and really kind of communicate the official information from the server to the client to make sure that the client actually knows 100,000% that this is what the actual match score is. If you're doing a lot of the data calculations on the client and never getting them from the server, there is actually a chance that that data could become desynced from what is actually real on the server side. So that's why I think it's perfectly fine to do some of your calculations on the client side, but we also do want to make sure that we verify that information from the server side and update the client whenever the client has wrong or outdated or desynced information. It's just good and helpful to get this information from the server side, even though we could probably do it and only rely on the client side. And also, firing off a remote event, especially in this circumstance, is not taxing at all. So it's not like this has any performance impact that we have to worry like, oh my gosh, let's just do everything on the client. No, that's not even something that you have to worry about here. And that still holds true if you were to fire this off like 10 times per second. Anyways, now that we've replicated that information to the client, the next thing that we want to do is actually check the score and determine if we should end the match. So let's go ahead and create a variable for the max match health. So we're going to say max match health equals, and again, we're going to use the opponent's config.get max match health. We'll pass through the match.opponent, and now we'll create a variable called match1, which, if the match score is greater than or equal to the max match health, then that means that the player has won. We'll also create a variable for match loss, and the way that we can determine if the player has lost the match is by comparing the score to being less than or equal to the number 0. Now you might be thinking, well, do we actually have to create the match loss variable? Couldn't we just use match 1 and then an else statement? If they did not win, then they lost. But unfortunately, we cannot do that, and you'll see why in just a second. Now, I actually just realized that I misspelled this variable. It's actually match lost, not match loss with 2 S's. Anyways, now we're going to say if match won or match lost, then, and then we're going to go ahead and use the stop match function and pass through the player. So that's why we're not able to use an else statement, because we only want to stop the match if the player has won or if they have lost. And now that's actually all that we have to do inside of this function. Yup, that's it. That's all of the match logic. So remember how earlier I was explaining that the opponent is able to tap 2 times per second, where the player can tap up to 5, or, well, we actually set the limit up here up to 10 times per second. That was all related to this logic right here. With that being said, let's go ahead and actually use this function, and we're going to use this function in our onStart function, so when the game first starts up. Now, rather than just simply calling this function, we actually want to use task.spawn and then call this function. Now, the reason that we're using task.spawn here is because this function uses a while true loop, and the while true loop just never ends. So to be able to easily demonstrate this to you, let's say that we actually were going to call this function right here, and this is how we were going to do it. When we call this function, since it is a while loop and the while loop never ends, the function will never reach the code below this while loop because the while loop never ends. So these events will never actually be connected to those functions. But if we wrap that in a task.spawn, that will allow this function to be called as normal, and it'll prevent that function from stalling this script and stalling past this line right here, and instead it'll allow the rest of this code to be executed as well. So yeah, hopefully I explained that well enough for you to understand. And now also at the same time, where you put the task.spawn or where you actually call this function doesn't actually matter. You can call it before or after connecting those events. That does not matter at all. And now, with all that being said, we're actually fully finished with creating the match service, so we can go ahead and close out of this module script, and we're actually finished scripting this entirely on the server side, so we can go ahead and collapse the services folder as well as the server script service. Since we're finished with scripting this on the server side, what does that mean? Well, that means that we can get started scripting this on the client side. So to do that, we're going to go inside of the starter player, inside of the starter player scripts, and inside of the controllers folder. Now inside of here, we actually already have 2 module scripts, and we're just going to go ahead and delete both of those. Then inside of the controllers folder, we'll go ahead and create a brand new module script, and we're going to rename the module script to be called match controller. Then of course, let's go ahead and update the module variable to be called shared. And then directly above the shared variable, we're going to go ahead and create a variable called local, which will also equal a table as well. Now, towards the top of the script, we're going to need to get a couple of services. So we'll go ahead and create a variable for the player service. We also need a variable for the replicated storage, and the last service, which is the workspace. Next, we're going to want to go ahead and create a variable for the local player. So we're going to call this variable player, and we're going to set that equal, and we're going to set that equal to players.localPlayer so that we can actually get the client's player. Below that, we also want to make a variable called remotes, and that's going to be equal to the remotes folder inside of the replicated storage. Now, this module, being the match controller, is going to be required by a couple of other controllers that we're going to create. Because inside of here, we're actually going to store the state of the current match. And what I mean by the state is the actual progress of the match. So let's go ahead and create the state. In order to do that, we're going to say shared, and the name of the variable that we're going to be adding to this table is going to be called state, and that's going to equal a table. Now, this table is going to contain a couple of different properties. The first property is going to be opponent, and by default, this is just going to be set to a blank string. The second property is going to be score, and by default, that will be equal to 0. And we'll have one last property, which is going to be called started, and of course, we'll set that to false by default as well. And now, of course, using remote events, we'll go ahead and make changes to the state variable when the match begins, as the score changes, when the match ends, and probably a couple of other times as well. So now that we have the state variable created, we want to create a couple of different functions for modifying the state. Although I think the easiest way to do this is to begin by sort of hooking up the networking. So let's go ahead and create our onStart function. We're going to say function shared.onStart. Of course, it's not going to have any parameters. Now we're going to use our remotes variable, and the first remote that we're going to set up is going to be the match countdown remote event. Now, of course, before we hook this up, let's go ahead and actually create the function for it. So we're going to go ahead and say function. We'll add this function to the local table, and it's going to be called start countdown. Now it's going to have two parameters. The first parameter is going to be the opponent, which is a string, and the second will be the score of the match, and that's going to be a number. Now, this is basically going to be the very first thing that gets fired off whenever a player enters a match. So when we start the cooldown on the client, what we first want to do is go ahead and make some adjustments to the state. Now, looking at our parameters, we are receiving the opponent and the score of this match. So let's go ahead and update those things inside of the state. So we're going to say shared.state.opponent equals, and then we'll set that equal to the opponent. Then we'll go ahead and update the score of the state as well, and that's going to be equal to the score that's passed to this function. Now, those are the only changes that we're going to make to the state inside of this function, but there's a couple of other things that we're going to want to do when the countdown begins. When the countdown begins, we're actually going to want to freeze the player's movement so that they're not able to move around their character. We're also going to teleport the player's character directly across from the NPC, so it looks like they're both standing a little bit apart from the table. And the last thing that we're going to want to do is actually hide all of the proximity prompts so that the player cannot see them while they're in a match. And I've also created comments with these three things right here because I think it definitely would help the visual learners out. But we're going to come back and create all of these separate things towards the end of us creating this match controller. For right now, we're just going to go ahead and set up all the different functions that modify the state. So going back to modifying the state, we have ultimately finished creating the start cooldown function. So let's go ahead and hook that up to the networking of the match countdown remote event. So we'll go back up to here and we're going to say on client event :connect, and then we'll go ahead and connect this remote event to the start countdown function. Now let's go ahead and take a look at our next remote event, which is actually going to be match start. So we'll go ahead and create another function, which is going to belong to the local table. And this function is going to be called start match. Now this function is extremely simple, and all we're going to do is make one adjustment to the state. So we're going to say shared.state, and we're going to go ahead and update the started property, and we're going to set that to true. And like I said, this function is very simple, so we're actually done with creating this. Let's go ahead and hook this up to the networking as well. Now I'm just going to go ahead and copy this part of the code, paste it right down to there, but let's go ahead and make sure that we hook it up to the start match function. Let's take a look at our next remote event, which is actually going to be the match progress remote event. And we'll go ahead and create another function, which is again going to be a part of the local table. And this function will actually be called update score. And it's going to have one parameter, which we'll call score, and that's specifically a number. Now this function is also pretty simple. Again, all we're going to be doing is updating one property inside of the state. So we're going to say shared.state, and I bet that you can guess what property we're going to update. That is the score property, and we're going to set that to the brand new score. Now that we've created that function, let's also go ahead and hook that up to the networking as well, and we'll go ahead and hook that up to the update score function. Now we actually have one more remote event that we're going to go ahead and hook up to, and that is the match end remote event. So let's go ahead and create another function, again a part of the local table, and this is going to be called end match. Now this function is not going to have any parameters, and now what we want to do is basically clean up the state and reset it to its default values. And we can literally just take a look right here. What are its default values? Well, we can actually literally just go ahead and copy and paste this if we want to. So we can literally just paste that in there. We're just going to say shared.state equals the table with all of the default properties. Along with resetting the state, because of what we do in the start cooldown function, we also need to basically undo all of these actions as well. So we need to unfreeze the player's movement and we need to unhide the prompts. So I'm going to go ahead and paste those comments down here. These comments don't really matter for you guys. It's more of just a visual thing until we actually get around to creating those functions, and then we'll remember to use those functions right down here. And now, since we've pretty much fully created this function, let's go ahead and hook that up to the networking. So that on client event :connect local player.endMatch. Cool, so now we've created all of our primary functions, at least the ones which modify the state, and we've hooked them all up to the networking as well. With that being said, let's scroll all the way down to the bottom of our script, and we'll begin creating some more functions for those specific things that we want to do whenever the match starts and whenever it ends. Now we'll go ahead and start off by creating a function, which is going to be a part of the local table, and we're going to call this hide prompts. It's going to have one parameter, which is going to be hide, and that's going to be a boolean. The way that we're going to use this parameter is if true is passed through to this function, then we will hide all of the proximity prompts, and if false is passed to this, then we'll unhide all of the proximity prompts. Now, if we think back to how our proximity prompts are actually set up, each NPC located inside of the NPCs folder inside of the workspace actually has a proximity prompt stored inside of it. So how do we get these proximity prompts? Well, let's go ahead and iterate through all of the descendants of the NPCs. So we're going to say for underscore workspace dot NPCs get descendants do. And then all we have to do is check if the descendant is a proximity prompt. And if it is a proximity prompt, then what we're going to do is just modify the enable property of it, and we're going to set it equal to not hide. So when we call this function, if we pass through true, that will cause all of the prompts to be hidden. So the enable property will actually be false, because it would be the opposite of what hide is, which hide would be true. And then of course, if we pass through false to this function, then all of them would be unhidden. And now that we've created that function, let's go ahead and use it. So inside of the endMatch function, let's go ahead and say local.hidePrompts, and we'll go ahead and pass through false. We can also go ahead and delete that comment. Then we'll go to the start cooldown function. We'll again call hide prompts, but this time we want to pass through true. And there we go. We've now called that function exactly where we need to. So now that we've set that function up, let's go ahead and move on to the next one, which is going to be for teleporting the player across from the NPC. So we're going to say function. Again, it's going to be part of the local table, and we're going to call this function teleport player. And it's going to have one parameter, which is going to be called opponent. And of course, that's going to be a string. Now, first, we're going to go ahead and create a variable for the NPC model. So we'll create a variable called NPC. And how do we get the NPC model? Well, inside of the workspace, we have the NPCs folder, and we can index that with the name of the opponent. Then we'll also create a variable called table part. And this variable refers to the part that's stored inside of the NPC, which we use as the table. And we can access this by saying NPC and then index that with table. Then let's go ahead and create a variable for the player's character. So we'll call that character, and we'll just say player.character. Then we'll create a variable called new position. And now what our goal is basically to teleport the player a small distance away from the table, but at a very specific spot so that they're facing directly across from the NPC. So in order to do this, we're going to say tablepart.cframe.position, and then we want to add that to a new vector 3. And with this vector 3, all we're going to do is modify the z-axis. And we want to subtract 2.5 from the z. So now that we've got the character's new position, we also want to create a variable for the character's new orientation as well, so that the character faces towards the NPC. So we're going to go ahead and create a variable called new orientation. And to get this, we're again going to use the C-frame of the table part, but this time we don't want to use the position. We instead actually want to use the look vector. And then we're going to add that to the position from the C-frame. So we're going to say tablepart.cframe.position. Now we've gotten the new position and the new orientation. Let's go ahead and move the character. To do this, we're going to say character, and then we'll use the pivot to method, and then we'll create a brand new C-frame inside of here. The first argument that we're going to pass through to the C-frame is going to be the new position, and the second, of course, is going to be the new orientation. And now this function will teleport the player directly beside the table and across from the NPC. Now, if you want a good explanation for how the new position and new orientation is calculated, I would definitely recommend you ask ChatGPT, because I'm not going to lie to you, that's how I came to this solution. I am terrible at C-frames, vector math, and everything related around that. I really can't explain to you why we add the look vector plus the position. The new position is pretty easy to understand, but this is definitely a weak point for me. So again, if you really want to learn more about this, you could literally just put this code through ChatGPT and ask it to explain it to you, and you should have a much better teacher teaching you that subject than me. With that all being said, we are finished creating the teleport player function, so let's go ahead and use it. We're actually only going to use it inside of the start countdown function. So let's go ahead and replace this comment. We'll say local.teleportPlayer, and we'll pass through the opponent. And now we can see that we clearly have one more function to create, and let's go ahead and create it. This again is going to be a part of the local table, and we're going to call this function freeze movement. And it's going to have one parameter, which is going to be freeze, and that's going to be a boolean. Now with this function, all we actually want to do is if we want to freeze the player's movement, we're just going to set their walk speed to 0. And if we want to unfreeze their movement, then we're going to set their walk speed back to 16, which is the default. So let's go ahead and create a variable inside of here for the player's character. We'll of course go ahead and say player.character. And now if we don't get the character, then we're going to go ahead and stop the function right there. Then we'll go ahead and create a variable for the humanoid inside of the player's character. So we'll say character, find first child of class, and we'll look for a humanoid. And again, if we don't find the humanoid, then we want to go ahead and stop the function right there. Now that we know that we've gotten the humanoid object, we want to go ahead and adjust the walk speed property of it. And if freeze is true, then we want to set their walk speed to 0. Otherwise, we want to unfreeze them, so we would set their movement speed back to 16. And I got a little bit ahead of myself here. I kind of forgot the equal symbol, which is kind of crazy. I don't think I've ever made that mistake before. But anyway, don't forget the equal symbol, and this is what the if statement should be. And now we're actually finished with creating this function. So let's go ahead and use this as well. First, we'll go ahead and add this to the end match function. So we'll say local.freeze movement. When the match ends, we want to unfreeze their movement. So we'll go ahead and say false. And then going back to the start countdown function, we also want to call the freeze movement function here as well. And we'll pass through true to here because we do want to freeze the player. Okay, with all those functions being created, with everything hooked up to the networking, that is actually all we're going to do inside of this match controller script. So we can go ahead and exit out of that. So now that we're finished with the match controller, we're going to go ahead and create the camera controller. Now, we're going to need a lot of the same variables that we already create inside of the match controller. So let's just go ahead and duplicate this. And then we'll rename one of them to be called camera controller instead of match controller. We'll go ahead and open that up. And now for the services, we do not actually need the player service, but we do need the replicated storage as well as the workspace. And we need one more service as well. And that is the tween service. So let's go ahead and create a variable for that. Of course, since we're not using the player service, we do not need the player variable. Now let's go ahead and delete all the state data. And we can also delete all of these other functions as well. Now, we still kept the onStart function because we are actually going to use this. We're only going to be using 2 remote events though. We'll be using the match countdown remote event because again, this is the first remote event in the chain. So when this remote event is fired off, we want to reposition the camera and focus it to sort of look at the table between both the player and the NPC. And since we're connecting to the match countdown remote event to handle that, we're also going to need to hook up to the match end remote event. So we can go ahead and delete these other 2. And the reason that we're going to hook up to the match end event is because when the match ends, we of course want to reset the player's camera back to how it was originally set up. So the function that we connect those events to, let's just go ahead and delete both of them. And we'll just leave that blank for now because that gets rid of the red underline. And it just kind of annoys me to see that red underline. Now, we're actually going to create a couple of variables before the onStart function. We'll add these to the local table because we don't need to share these variables with any other scripts. So the first variable that we want to create is going to be called camera. And the value of this is actually going to be the current camera property of the workspace, which, if we look at the description, it is the camera object being used by the local player. Next, we'll create a variable called camera last C-frame, and we're going to set that to nil by default. But what we're going to use this variable for is to actually store the C-frame of the camera before we modify it to stop sort of looking at the player like it usually does and focus on the table. So since we're saving that with this variable, we'll of course use this variable to revert the player's camera back to its original C-frame when the match ends. Then we'll create a variable called original FOV. And by default, we're going to actually set this to the camera's FOV. So we're going to say local.camera.fieldofview. Now, we'll be using this a little bit later on in the script because we're going to create an effect which when the player clicks, we're actually going to adjust the camera's FOV to kind of give it like a zoom in effect. And of course, we need to save the original FOV to go back to. And then finally, we're going to create one more variable, which is going to be called last click time. And we're going to set that to 0 by default. Like I said, we're going to have an effect whenever the player clicks, we're going to adjust their FOV, and we'll be using this variable inside of that function as well. So for right now, we really don't have to worry about these, but these other 2 variables we will be using in just a second. So under our onStart function, let's go ahead and create our first function. This is going to be a part of the local table, and we're going to call this function Tween To Table. And it's going to have one parameter, which is going to be opponent, and that of course is a string. Now, this function is going to be called by the match countdown event, so we could actually just go ahead and connect them right now. And there we go, we have them connected. The reason that I'm saying that though, is because when the match countdown begins, this is when we actually want to tween the player's camera from the usual perspective of looking at the player, and we want to reposition and refocus the camera onto the table between the opponent and the player. Now, first things first, inside of this function, we need to create a variable for the table part of the NPC. Of course, to do this though, we have to actually create a variable for the NPC. So let's go ahead and start off by doing that. How do we get the NPC? Well, of course, workspace.npcs. Inside of the NPCs folder, we'll index that with the specific opponent. Then we'll go ahead and create the table part variable. So inside of the NPC, we have the table. Now, when we call this function, we want to go ahead and set the camera last C-frame. Now, when we call this function, we want to set the camera last C-frame so that we can use that whenever we want to revert the camera back to where it originally was. So we're going to say local.camera last C-frame, and we're going to set that equal to the local.camera.cframe. Now, we actually want to adjust a property on the camera. So we're going to say local.camera, and the property that we want to adjust is actually called camera type. And now we need to set this to an enum, and that enum is the camera type. Now, the default camera type is actually custom. So this is the camera perspective where it's sort of above the player. But what we want to do is we want to actually change the camera type to scriptable, which will allow us to actually control and play around with the camera and stop Roblox default scripts from actually holding control of the camera. So now that we've made it possible for us to actually adjust the camera, we're going to go ahead and prepare for that. So let's go ahead and create a variable called table C-frame. And of course, this is going to be set to the table parts C-frame. Okay, this is a little awkward. Before we can determine where we want to reposition the camera to, we actually want to scroll back towards the top and create a couple of constant variables. So we're going to create a variable, and when we write constant variables, we want to write them in all uppercase. And the reason that these variables are called constant is because we do not plan to change these variables. So the value will always remain the same. And why is this useful? Is because when we open up the script, we can easily see variables that we can modify, which will have a drastic impact on our system. It's a lot easier for us to come back to the script and look at just a couple of variables that we need to modify to change specific things in our system, rather than scrolling through all of the code, thinking through all of the logic, remembering everything, and then making changes that way. With that being said, the first constant variable that we're going to create is going to be called offset_difference. And we want to set this to a vector 3. Now, for the x, we're going to say 5.15. For the y, we're going to say -6. And for the z, we're going to go with 2.5. Now, what this variable is it's actually the difference between the table and the camera's position. Now, I'll show you how we get the offset difference in just a second, but let's finish creating these last few constants. The next one that we're going to create is going to be called zoom per click, and we're going to set that to 4. Now, what this is how much we actually modified the player's FOV each time they click to give a sort of zoom in effect. The next variable that we're going to create is going to be called max FOV, and we're going to set that to 45. So this is basically how far zoomed in the player's FOV can actually go. If we don't limit it, things can begin to look really weird, and it kind of ruins the entire effect. Then we'll create one final constant, which is going to be called zoom out delay. And to make this effect really look visually appealing, what we're going to do is we're basically going to create a timer, and this is going to specify the amount of seconds that there must be between clicks for the camera to zoom out. So each time the player clicks, the camera's going to zoom in. And then if the player doesn't click within like a half a second, because we're going to set this to 0.5. So if the player doesn't click again within half a second, then the camera will begin to zoom out. So it'll go in the opposite direction. And if that sounds confusing, don't worry. You'll see once we actually get around to scripting this and we finish it. Now, let's look back at the offset difference and determine how we actually get this. Now, it's a lot easier for me to actually show you how we get this number rather than me just explaining it. So let's take a look back at our game. And now what we want to do is we're going to use this first NPC right here, and we're going to reposition our camera from the specific angle that we would like to position the camera and focus it to look towards the table. So what I mean by this is, let's say that we want the camera angle to basically be right here. So this camera angle kind of focuses on the table and we're moved back a little bit from the table and the NPC. Now that we position our camera, let's go ahead and actually calculate the offset. So what we want to do is we want to go inside of the workspace and we want to look at the camera. The camera contains a property called C-frame, and of that C-frame, it also has a position. Now, we're going to be using the command bar at the bottom of our studio to actually perform the calculation for us so that we don't actually have to do any math. In order to do this, what we're going to do is we're going to say print. Then inside of here, we're going to create a brand new vector 3. So we're going to say vector3.new. And then we're going to go ahead and copy the position from the C-frame and paste that directly inside of this vector 3. Next, what we want to do is we want to get the position of this table. So in order to do that, we have to go inside of the NPCs folder and we have to actually find whatever NPC we're looking at. So we can see that we're looking at John. We'll expand this and then we'll find the table part. And then if we select the table part, we can see that also has a C-frame property, which also contains a position property inside of it as well. Now, we're going to go ahead and copy this position, and then we'll go back inside of our print statement. And now we want to create a brand new vector 3, but we want to create this vector 3 before our previous one. So we're going to say vector3.new, and then we'll paste our position inside of this brand new vector 3, which should be the first vector 3 inside of this print statement. Then after that, we're going to include a minus symbol, because what we want to do is we want to subtract the camera's position from the position of the table. So now we can go ahead and hit enter, and we can see that 5, -5, 1.4 has been printed out. So that's how we can actually calculate the offset difference. So going back to our module script, where we have the offset difference, looking at the offset difference, we already have this set to 5.15, -6, and then 2.5. This is slightly different than the number that we got printed inside of the output, and that's just because our camera's position was a little bit different. Now, I'm going to stick with this offset difference here because this is what I originally went with, and I like that the best, but of course you can choose to play around with the positioning and set it to whatever you actually like. So, now that we've created all those constants, we can return back to our Tween To Table function, and we can continue creating this. So, after our table C-frame variable, we want to go ahead and create a variable for the target position, which is where we would like to move the camera to. Now, how do we determine this? Well, we'll go ahead and use the table C-frame, More specifically, we want to use the position of it, and we want to actually subtract the offset difference from that position. We then need to create a variable for the target look vector. This will allow us to basically adjust the orientation in which the camera is facing so that it actually faces and kind of focuses on the table. Now, in order to get this, we're going to use the table.cframe, and we actually want to use the look vector of that C-frame. And then we're actually going to add the position from the table C-frame to the look vector. And now that we've created those two variables, we can actually go ahead and create the C-frame. So we're going to create a variable called target C-frame, and we're going to go ahead and create that C-frame. So we're going to say C-frame.new. For the first argument, we'll pass through the target position, and for the second one, we'll go ahead and pass through the target look vector. And now that we've done that, we can go ahead and begin creating our tween. So I'm going to create a variable called tweeninfo, which is going to be equal to tweeninfo.new. Now, the first parameter is time, which means how many seconds do we want this tween to actually take? And I want it to take about 0.6 seconds. Then we can specify the easing style. So I'm going to say enum.easingStyle, and I want to go with quad. And then we need to specify the easing direction, and we're going to go with in. Now that we've created the tween info variable, we also want to create a variable which is going to be called tween props, and this is going to be equal to a blank table. Now, I'm calling this tween props, and what I mean by props is properties. So we're going to use this table by adding all of the properties that we want to modify of the instance in which we're going to tween. The reason that we're handling it this way is because I think it is a lot cleaner to add all of those properties to this table rather than specifying those properties in the function call where we use tween service create. Now, if any of that's confusing to you, don't worry, you'll likely understand exactly what I mean in just a second. So with the tween props table, we want to go ahead and add the C-frame property to this because we want to modify the camera's C-frame. Now, what do we want to set the C-frame property to? Well, we want to set it to the target C-frame. So now that we've specified the property that we want to actually tween, let's go ahead and actually create this tween. So we're going to create a variable called tween, and then we'll use the tween service, and we'll use the create method of the tween service. Now, the instance that we want to tween is the camera, so we're going to say local.camera. Then we can pass through the tween info, and then finally we can pass through tween props, which is the property table. And now that we've created the tween, let's go ahead and use it. So we're going to go ahead and say tween :play, and that will cause the tween to actually play. And now that's all that we're going to do inside of this function. So whenever this function is called, the player's camera will be tweened from looking at the player to actually being a little bit above the table and looking directly at it. So now that we've created this function in which we actually tween the camera, we also need to create another function to do the opposite of this. So we want to revert the tween and basically tween the camera back to the player. So below this function, let's go ahead and create another function, which is also going to be a part of the local table. And this function will be called Revert Tween, and it's not going to have any parameters. Now, the first thing that we're going to do inside of here is create a variable for the tween props. So we'll set that to a blank table, and then let's go ahead and add a property to this. Now, what property do we want to modify of the camera? Well, of course, we want to modify the C-frame. And what do we want to set the C-frame to? Well, we want to set it to the camera's original C-frame before we modified it. And how can we access that? Well, remember, we created that variable earlier of the local table, which was called camera last C-frame. So now that we've created the props, let's go ahead and then create the tween info. And honestly, I'm just going to use the same tween info that we created up here. So let's just go ahead and copy and paste that. And now that we've created the tween info, let's go ahead and create the tween. So we'll say tween service :create. The instance that we want to tween is the camera. Then we can just pass through the tween info and the tween props as well. Now that we've created the tween, let's go ahead and use it. So we'll say tween play. And now there's one more thing that we actually have to do inside of here, and that is resetting the camera's camera type property. Because remember, in the tween to table function, we changed the camera type to scriptable, and now when we revert the tween, we want to put it back to custom. So in order to do this, what we're going to do is we're actually going to listen for this tween to be completed, and then we'll revert the camera type. So we'll go ahead and use connect, then we'll create an anonymous function inside of here, and then let's go ahead and reset that. So we'll say local camera.camera type equals, and then we'll say enum.camera type. And now that reverts the camera back to its previous camera type. Now that we've finished creating this function, when are we going to use it? Well, let's go back to the onStart function, and we want to connect that to the match end event. So let's go ahead and say local revert tween, and there we go. Now, with all that being said, we are almost done inside of the script, but we actually need to create one last function. So let's go towards the bottom of our script, and we'll go ahead and create this. Now, this function is going to be a little bit different. It's actually going to be a part of the shared table. And this function is going to be called zoom, and it's not going to have any parameters. Now, this function is going to be called from another script whenever the player clicks. And whenever the player clicks, we want to make a little zoom in effect, so that's why we're going to be adjusting the camera. Now, remember earlier how we created the last click time variable? Well, the first thing that we're going to do inside of the zoom function is actually set that. So we're going to say local.lastClickTime, and now we're not actually going to use os.time here. Instead, we're going to use tick. Now that we've set the last click time variable, the next thing that we're going to do is create the tween props table. And now the property that we want to modify with this tween is actually going to be the field of view. So we're going to say tween props dot field of view, and make sure you capitalize this all the exact same way. And what do we want to set the field of view to? Well, we're going to use the camera's current field of view, and we're going to subtract the zoom per click from that field of view. Now, before we actually adjust the field of view, we want to make sure that the max field of view has not been reached because we don't want them to zoom in too far. So we're going to create a variable called isAtMaxFOV. And how are we going to determine this? Well, we're going to compare the current field of view of the camera and check if that is less than or equal to the max FOV. And now, if it is not at the max FOV, then we want to go ahead and perform the tween. So let's go ahead and create a variable called tween, which is going to be equal to the tween service, create. What do we want to tween? Well, we of course want to tween the camera. Now, I didn't create any tween info here, and that's because this one's pretty simple. We're just going to go ahead and say tween info.new, and the only argument that we're going to pass through to here is 0.3 because we want this tween to take about 1/3 of a second. And then finally, we'll go ahead and pass through tween props. Now that we've created that tween, let's go ahead and play it. So we'll go ahead and say tween play, and there we go. We're now playing it. Now there's one more thing that we have to do inside of here, and that's actually trying to reduce the zoom in effect. So we're going to use task.delay here, and the amount of time that we're going to wait is actually going to be the zoom out delay variable that we created earlier. Then we'll create an anonymous function inside of here, and the first thing that we want to do is get the current time. So we'll create a variable called current time, which is going to be equal to tick. Now that we've gotten the current time, we want to check if 1 second has passed since the last click. So we're going to create a variable which kind of has a long name. It's going to be has been second since last click. And how do we determine if it has been a second since the last click? Well, we would use the current time, and then we would subtract the last click time from that. And then we want to check if that is greater than the zoom out delay. And now if that is true, so if there has been a second since the last click, then we're going to go ahead and begin to actually zoom out. So we're going to create a variable inside of here called tween props, which is going to be equal to a blank table. What property do you think we want to modify? Well, again, it's going to be the exact same one. So we're going to say tween props dot field of view. Make sure the capitalization is all correct. And we're actually going to set that to the original FOV. Now that we've done that, let's go ahead and create the tween. So we're going to say tween service, create. What instance do we want to tween? Well, of course, that is the camera instance. Then we'll create a tween info inside of here. This one will actually allow to take up to 1 second. And then for the final argument, we'll pass through the tween props. Now that we've created that tween, all we have to do is actually go ahead and play it. And there we go. That's actually all that we have to do inside of the zoom function. We are completely finished with it. Like I said, though, we will not be using this function inside of the script, but we will be using it in the final one that we create. So with that being said, we can go ahead and close out of this script, and we can also collapse the workspace. And now we can go back to our controllers folder and finally create the last controller that we have left. Now, to create our last controller, let's go ahead and duplicate the match controller. And we'll rename this final one to be called GUI controller because, of course, we'll now begin scripting the GUI. So, hopping inside of the script, we still are going to want to have a variable for the player service, the replicated storage, and the workspace, but we're going to use a couple of other services as well. So, in addition to all of those, we also want to get the tween service, and we also want to get the user input service as well. Now that we've created all of those variables, we still want to create the player variable, but in addition to the player variable, we also want to create a variable for the player's GUI. And to do this, we're going to say player, wait for child, and then we're going to wait for the player's player GUI to be created. And now we want to require both of our other controllers. So first, we'll create a variable for the match controller, and to get the match controller, all we have to do is say require script.parent, and then we specify the match controller. Now again, we want to get both of these controllers, so in addition to the match controller, we also want to get the camera controller as well. So let's go ahead and create a variable for both of those. And we need to require one more module. This is actually from the replicated storage, and it is the opponent's config. How do we get this? Well, we once again use require. This time though, inside of the replicated storage, we have the configs folder, and inside of there, we have the opponent's module script. Then after that, we still want to create a variable for the remotes folder, but we want to create a few more variables as well. And these are specifically for the actual GUI. So we'll go ahead and create a variable called GUI, which is going to be equal to the player GUI. Then we want to use wait for child, and we want to wait for the match screen GUI to be added to the player GUI. Inside of the GUI, we have a frame. So let's go ahead and create a variable for that. We'll go ahead and say GUI.frame. We don't only have one single frame though, we actually have 2 frames inside of there and even a text label. So next we'll go ahead and create a variable called click, and now we'll go ahead and get the click frame. And like I said, we also want to create a variable for the text label as well. So we're going to say local status equals GUI.status. Now that we've created all of those variables, we also want to create a couple of variables for things inside of the frame. So we'll first create a variable for the progress bar, And to do that, we'll just say frame.progress. We then want to create a variable for the opponent frame. So we'll go ahead and create a variable called opponent, and we'll set that equal to frame.opponent. Similar to the opponent frame, we have a self frame that we also want to create a variable for. So we'll say frame.self. And the last variable that we want to create is going to be called title, and that is for the title text label inside of the frame itself. Cool. So now that we've created all of those variables, what we can do is pretty much delete everything inside of here. I'm just going to go ahead and leave the onStart function, but I'll go ahead and delete all of the other functions inside of here as well. And since we deleted all of those, I'll delete what we actually connect all of these remote events to, but I will just leave the remote events because we are actually going to use all of these. Now, we actually want to create two constants. The first constant is going to be called max taps per second. And what we mean by this is how many times we want to allow the player to click per second. And I'm going to set this to 10. Then we'll create one more constant, which is going to be called frame_positions. And that's actually going to be equal to a table. And inside of this table, we are going to store two key value pairs. For the first key, we're going to say hidden. And for the value of that, we're actually going to use a udim2.new. Now, for this udim2, we're going to set the x scale to 0.5, the x offset to 0, the y scale to 1.5, and finally, the y offset to -50. Then, for our second key value pair, the key will be visible, and we'll again create a udim2.new. It'll be pretty similar to the hidden udim2. So for the x scale, we'll say 0.5. For the x offset, we'll say 0. But now for the y scale, we'll actually use 1 instead of 1.5. And then still for the y offset, we'll use -50. Now, what the frame positions variable is going to be used for is when we actually want to sort of tween the little progress bar that appears towards the bottom of our screen when the player enters a match. So when we want to hide that frame, we'll basically increase its Y scale position by 0.5 because that will actually make the frame move in the downward direction, and that'll allow us to basically tween it off screen. And then of course, when we want to make it visible, we'll set the Y scale to 1 so that we can actually see it. Now, before our onStart function, we need to create another variable. This is going to be a member of the local table, and this variable is going to be called clicks in last second. And by default, we're going to set that to 0. Now, we of course need to keep track of the player's taps/clicks because we want to limit them by using the max taps per second variable. So we don't want them to go over the maximum of 10 clicks per second. Now, inside of here, we're going to be creating a good amount of functions. And of course, a lot of functions are going to use the other functions. So in order to try and cause as little confusion as possible and to prevent us from having to go back to previous functions that we created, then go back to the ones that we just created and different things like that, we're going to be kind of working in an opposite order. So the first thing that we're going to do is create a brand new function, which is going to be a part of the local table. This function is going to be called update CPS, and it's not going to have any parameters. Now, CPS doesn't stand for the thing that you probably think it stands for, because what we mean by CPS is actually clicks per second. Now, this function is really simple. We're going to create a variable inside of here called CPS, and now we need to calculate the amount of clicks per second. And this is actually incredibly easy to do because of a variable that we created earlier. Now, we're actually going to use a function from the math library, which is called min. And what math.min does is it actually returns the minimum value among the numbers passed to this function. Now, we're going to pass two numbers to this function. The first number that we're going to pass is the clicks in the last second, and the second number that we're going to pass is max taps per second. So we're using this to basically make sure that we never display more clicks that the player is actually clicking than the max taps per second. So now we'll go ahead and update the text of the title text label, and we're going to set that equal to start tapping, exclamation mark. Then inside of parentheses, we're going to include the clicks per second. But before we add a closing parenthesis, we want to say /s, because of course it would say something like 5/s, so 5 clicks per second. And then we'll include the closing parenthesis just like that. And like I said, this function is going to be very simple, and that's all that we're going to do inside of here. Now we'll go ahead and create our next function, and we're going to do that before the local update CPS function. So we're going to say function. This function is going to be a member of the local table, and it's going to be called CPS Loop. And what we're going to do inside this function is we're going to use a while loop to continuously update the clicks per second that is displayed to the player. Now, since we're using a while loop inside of this function, when we call this function, we don't want it to actually stall and prevent all of the code from running after where this function is actually called. So we're going to go ahead and use a task.spawn inside of here. Then we'll create an anonymous function, and we'll create our while loop inside of this task.spawn to prevent our code from stalling. So let's go ahead and create our while loop. Now, the variable that we want to use in our while loop is actually one from the state that we created inside of the match controller earlier. So we're going to say match controller.state, and now we want to actually use the started variable. So we only want this while loop to run while the started variable is true. And while this loop is running, what we're actually going to do is call the update CPS function. And now after we call that function, we also need to use a task.wait to prevent this function from being called a million times per second. And the amount of time that we want to wait is 0.1 seconds. So the clicks per second is going to be updated 10 times per second. Of course, you can update it more or less frequently depending on however you want to. Now, we're finished with creating this function, but we're not going to use it yet. We'll tie this all in towards the end. below the update CPS function, let's go ahead and create another function, which again is going to be a member of the local table. And this function is going to be called update progress bar, and it will not have any parameters. Now, the first thing that we're going to do inside of this function might seem quite odd if you haven't watched my simulator series. The reason that I say that is because the first thing that we're going to do inside of this function is actually use a task.wait, and we're only going to wait for 0 seconds. So now you might be thinking, wait, what is going on here? Okay, so basically, this function, we can actually hook up to the remote event, which is going to call it. So since we've already created this function, let's go back to our onStart function. And when are we going to call this function? Well, we're actually going to connect it to the match progress event. So we're going to say local.update progress bar. Now, this isn't the only location that we're going to be using this function. We will use it in other functions as well. But the reason that we hooked it up already is because we're going to be using the state from the match controller. And I'll show you exactly what I mean. So you can actually follow along with this. We're going to create a variable inside of here called score. And the value of that variable is going to be the actual score of the match, which we can get from the state inside of the match controller. So we're going to say matchcontroller.state.score. And now we've gotten the current score of this match. Now, I'm going to quickly take a look back at the match controller, and let's take a look at how the score is actually being set. So we have a function right here called update score, and this is actually how the score is being set. So when is that being set? Let's look at the event. That is being set by the match progress event. So the only time that the score of the state is being modified is when the match progress event is fired off from the server. Now, if we go back to our GUI controller, where do we call the update progress bar from? Well, going back to our onStart function, we also call the update progress bar from the match progress event. So now think about this. If both of these functions are called from the exact same event, which function will run first? Now you might be thinking, why does it matter which function runs first? And the reason that that matters is because inside of the match controller, this is the state that we're using in all of our functions and other module scripts. So it's very important for this state to be the only source of truth and to actually be accurate. So when both of these functions are being called by the same event, pretty much at the exact same time, whichever function is accessing the state, which is updated by one of these functions, we cannot be sure that the update progress bar function is actually accessing the state from inside of the match controller after the match controller has made its changes to the state. So that's why we're using task.wait0 here. This guarantees that the other function hooked up to the match progress, so the update score, will actually run before this function is ran. And since we're using task.wait0, we don't see any visible difference. Now, this isn't the only time that you're going to see me use task.wait0, but hopefully you now have an understanding of why we do that. So you might see this again in a couple of our upcoming functions. Okay, with that explanation out the way, let's get back to actually scripting this. So in order to update the progress bar, we just got the score of the match. The next thing that we need to do is get the max health of the match, because we'll use both of those to actually calculate the progress that has been made. So we'll create a variable called max match health, and to get this, we're going to use the opponent's config, and then we'll use the get max match health function. And we'll go ahead and pass through the opponent, which we can access from the state inside of the match controller. Next, we'll go ahead and create a variable called progress percent. Now, to calculate the progress percent, we're again going to use math.min here, and now we're going to calculate the progress. To calculate the progress, what we would do is we would divide the score by max match health, and that's how we get the progress. But we want to pass a second number through here because the number that we would get here should be between 0 and 1. But if for some reason it was to go over 1, we'll use math.min to prevent us from actually displaying a number greater than 1. So that's the number that we're going to pass through as the second argument. Now, something really weird occurs here, and it's literally something that I've never encountered before. But when I was creating this system, for some reason, I've had progress percent actually equal something called nan. This can actually occur from doing something like dividing 0 by 0. And when we print that out to our console, we can actually see NaN is printed out. And again, I don't think that I've literally ever encountered this before, but nan stands for not a number, and it seems to occur basically when you try to do impossible math. Now look, if you laugh at me, I don't blame you, but please let me know in the comment section down below, am I literally the only person who didn't know that there are numbers in math which cannot be used with each other? Like, you can't divide 0 by 0, for example. If you didn't know this, type 0 divided by 0 into your calculator, into the Chrome browser search bar, or wherever you can do math at. My calculator literally says error. And I honestly had no idea that that was even possible or a thing in math. Yeah, maybe I gotta go back to school. Anyway, hopefully I'm not the only person who didn't know that. I don't know, that's kind of mind-blowing to me. With that said, we want to check if the progress percent variable is nan. And now the way that we do that is by saying if progress percent does not equal progress percent, then we'll return end. So yeah, that is literally how you check if a variable is nan. You learn something new every day. Now that we've calculated the progress percent, we can use that number to adjust the size of the progress bar. And we're going to use a tween while doing this to make it look pretty smooth. So we're going to create a variable called tween info. which is going to be equal to tweeninfo.new. We want this to take about half a second. And for the easing style, we are going to use linear. We'll then create our tween props table, which of course is going to be a table. And what property do we want to tween here? Well, it is the size property. And what do we want to set the size property to? Well, we'll use a udim2. This time we can use from scale. Now for the X scale, we want to pass through the progress percent. And for the Y scale, we're going to keep that as 1. So the X size of the progress bar will be adjusted based on the progress made. Then let's go ahead and create the tween. Of course, we got to use the tween service to do this, and we'll use the create method. Now, what do we want to tween? Of course, the progress frame. We'll then pass through the tween info and the tween props table as well. So now we're tweening the size of the progress bar, but of course we have to play that tween to do this. And there we go. We fully finished creating the function for updating the progress bar. Now let's go ahead and create our next function below this one. This is again going to be a part of the local table, and this function is going to be called display status. It's going to have a single parameter, which is going to be called did win, and that's going to be a boolean. Now we're going to use this function to update the status text label and display that to the player whenever the match has ended, and what the status text label will display depends on if the player has actually won or not. So let's go ahead and update the text of the status text label. If the player did win, then we want to display you won exclamation mark. Otherwise, the player lost, so we want to display you lost. Then we'll go ahead and adjust the text color 3 of it as well based on if they've won or not. So we'll say status.textcolor3 equals, and again, if did win, then we'll create a color 3. I like to do from RGB. And if the player has won, then we'll use this green right there. Otherwise, we'll go ahead and create another color 3. And since the player has lost, we'll go ahead and use a red. Since we've updated the status text label, let's go ahead and display it. So we'll set the visibility of it equal to true. Now, we want to perform a tween on this as well, because what we're going to do is actually adjust the text transparency of it and basically make the text become almost invisible. Keep in mind that the text has a stroke around it, and that stroke will still be visible, so it kind of gives off a cool effect that I like. Of course, after you're done following this, you can make any changes that you want to it. So let's go ahead and create the tween info. We'll say tweeninfo.new. We want this fade effect to take about 1 second. And for easing style, we'll go ahead and use linear. Then let's create the tween props table. And again, what property do we want to adjust? We want to adjust the text transparency, and we want to set that to 1. Now that we've created the tween info and the tween props, let's go ahead and create the tween. So we'll say tween service, create. We'll pass through the status text label, the tween info, and the tween props. And now we've created the tween. Since we've created it, let's go ahead and use it. And now we want to do something after it has finished playing. So we'll go ahead and listen to the completed event. We'll connect that to an anonymous function. And what do we want to do after the text transparency has been fully tweened? Well, we want to actually make the status text label no longer visible. And then we'll also reset its text transparency for the next time that we display it. So we'll say status.visible equals false so that the player no longer sees it. And now that the player no longer sees it, let's go ahead and adjust the text transparency. And we'll set that back to 0 so that when we display it the next time, the player will be able to visibly see the text. And with that being said, we have fully finished creating the display status function. Now, we're not going to use this function yet. There's only a few more sort of one-off functions that we have to create before we start creating the ones that we actually connect to the networking. So the next function that we're going to create is going to be a part of the local table, and it's going to be called visualize tap, and it will not have any parameters. Now, in order to visualize the tap, we're actually going to move that click frame that we created earlier and reposition it to where the player's cursor at or wherever they tapped at. And then we're going to perform a tween on it to increase its size and then decrease its size. So first things first, we want to go ahead and get the player's mouse position. So we're going to create a variable called mouse position. And to get the player's mouse position, no matter if they even use a mouse or not, so this does also work for mobile, we're going to use the user input service. And we're going to use the get mouse location method. Now, if you read the documentation on this method, it doesn't mention anywhere that it does work on mobile. And in my opinion, it really makes you think that this only works when a player literally is using a mouse. The thing is, though, is that if you look on the dev forum, you can actually see multiple people reporting that this method works on all devices. And I believe that this is because maybe all devices have a virtual cursor, even mobile. And I guess that's moved around like a normal mouse would whenever the player, say, taps on the screen or maybe moves their finger while touching the screen and doing different things like that. So yeah, just because it seems like you shouldn't be able to use this method to do it, when I've tested this on mobile, it did work for me, and I've seen multiple other dev forum posts report the same thing, so we should be good to go. Now that we've gotten the location of where the player clicked, in order to calculate the position of where we actually want to move our GUI object to, we need to get the player's current screen size to calculate this. So we're going to create a variable called screen size. In order to get the screen size, we need to use the current camera inside of the workspace, because the current camera actually has a property on it called viewport size, which gives us the dimension in pixels of the client's viewport. Now that we've gotten the mouse position and the screen size, we can go ahead and convert this position to scale, because we're going to modify the position property of the GUI object that we want to move, and we're only going to adjust its position by using scale instead of offset. So we're going to create a variable called xScale, which is going to be equal to mouseposition.x. and we're going to divide that by the screen size.x. And we want to do the same thing for the y as well. So we'll create a variable called y scale. Then for the mouse position, we want to divide the y-axis by the screen size's y-axis as well. Now we'll use this positioning in just a second. But the first thing that we're actually going to do is adjust the size of this frame. The reason is because, again, towards the end of this function, we'll actually perform a tween on this frame to increase its size, and then we decrease its size all the way back down to 0. Instead of connecting to when that tween ends and then updating the size there, we'll just do it here and reset it to its original size before we display it to the player when the function is first called. So we're kind of handling this in the opposite way of how we handled the text transparency of the display status. Anyways, for the size, we're going to use a udim2, and we're going to use from offset. And we want to make this 50 by 50 pixels. Next, we'll go ahead and adjust its position. Again, we're going to be using scale for this, so we'll use from scale, and then we'll pass through the X scale and Y scale to the position. Now, we also want to update the anchor point with the exact same properties as well, but the anchor point actually accepts a vector2 instead of a udim2. But still, we'll pass through the X and the Y scale for those arguments. Now that we've adjusted where it's being displayed at, we can then begin animating its size. So we'll create a variable called tweeninfo. Of course, we'll use tweeninfo.new. We want this to take about a tenth of a second. And for the easing style, we're going to use linear. Then we'll go ahead and create our tween props variable, which of course is going to be a table. The property that we want to modify is the size, which of course has to be a udim2, and we'll be using offset for this. Now this is where we want to increase its size. So if its default size is 50, let's go ahead and increase that by 25 pixels on both axes. So we'll pass through 75 to both of those. Now we can go ahead and create the actual tween. So we'll say tween service :create. We'll pass through the click frame, the tween info, and the tween props. Then we can go ahead and use the tween. So we'll go ahead and play it. Now we want to listen for when this tween has finished. So we'll go ahead and connect an anonymous function to the completed event. And now we want to create and play another tween inside of here. So let's go ahead and create our tween. We'll first start off by creating the tween info. So we'll use tweeninfo.new. We want this to actually take a little bit longer. So we'll set it to 0.4, which is a little bit less than half a second. And again, we want to use the linear easing style. Then we'll go ahead and create our tween props table. What property do we want to modify? Well, of course, we want to modify the size. And again, we'll go ahead and use the from offset for udim2. And now we're actually just going to set the size to 0. So we're going to make it fully shrink. Then let's go ahead and create our tween. So we'll use the tween service :create. We want to adjust the click frame. Then we'll pass through the tween info and the tween props. And finally, let's go ahead and play that ending tween. And there we go. That's all that we have to do. So this function is going to be called whenever the player clicks. And whenever the player clicks, we're going to reposition it. Then we'll do a little animation to enlarge it. And then once it's fully enlarged, we'll shrink it down as well and finish out that animation. Now, below this function, let's go ahead and create another function, which is going to be a member of the local table. And this function is going to be called tap. And when is this function going to be called? Well, of course, it'll be called when the player clicks or taps on their screen. Now, the first thing we want to do inside of here is we want to actually go ahead and update the clicks in last second variable, and we're going to add 1 to that. Then we'll use a task.delay, and we want to wait 1 second because after 1 second, we'll go ahead and then subtract 1 from the clicks in last second. And that's how we can easily keep track of the amount of clicks in the last second. Now, after the player has clicked, we want to go ahead and update the CPS. So we'll go ahead and call that function. After we update the CPS, we're going to go ahead and create a variable for the CPS, which of course would be the clicks in last second variable. Now, we want to make sure that the player has not passed their click limit. So we're going to say if CPS is less than max taps per second, then. Now, if the player has not passed their max limit yet, then what we're going to do is fire off a remote event, which is actually the tap remote event. So we'll say fire server, and this is how we're going to communicate from the client to the server that the player has actually clicked. Now, there's actually one more thing that we want to do inside of here. We want to go ahead and create a variable for the player's power. Now, how can we get that? Well, inside of the player object, we have the leaderstats, and inside of the leaderstats folder, we have the power number value, and we want to go ahead and get its value. And now what we're going to do is we're actually going to update the state inside of our match controller because we want to update the score by the player's power. So we're going to say match controller.state.score, and then we're going to go ahead and add the player power to the score. Now remember, how the score is actually calculated, this is literally what we would do on the server side. The thing is though, to make this appear smoother to the client, we're performing this update on the client side, which will cause the GUI to update. And if for some reason the server was to say deny this remote event and not actually count the click on the server side, then when the score is next updated, that remote event will be fired to the player and set our score inside of the state to the actual current score that's stored on the server side. Now, that might have been really confusing. What I'm saying is that we're just making this slight change because it makes it more visually appealing to the client because the client updates instantly, whereas depending on the player's connection, the server might take a very small but visible amount of delay to actually cause our GUI GUI to update. And we don't actually have to worry about messing the score up here, because if for some reason the score was incorrect and we shouldn't have done this here, we already listened to that match score event and we literally set the score to the current score that's stored on the server side. So this variable will not get desynced or anything like that. Anyways, traveling back outside of that if statement, even if the player has surpassed their amount of clicks, what we still want to do is we actually still want to visualize their tap. In addition to that, we also want to animate the player's camera a little bit and make that zoom in. So we're going to use the camera controller, and we're going to use the zoom function from inside of there. And now there's one more thing that we want to do as well, and that is actually update the progress bar. And with that being said, we're done with creating this function, and let's go ahead and actually use it. Let's go back towards the top of our script where we have the onStart function, and inside of here, we're going to use the user input service because it contains an event called input began. Now we want to connect to this event, and we're going to have two parameters here. We're going to have the input and the game processed event. Now what this game processed event means, let's say the player actually taps on their screen and they click on, say, the leader stats or a GUI button or different things like that, then the game process event would be true because the game has already handled that event. So we'll actually use that in an if statement to determine if the player has clicked on something specific in their screen or if they're kind of just randomly clicking on the middle of their screen and not clicking on, say, a GUI button or different things like that. So we're going to say if game processed event, so if the game has handled the event or not, and now we want to check if the match has actually started. So we'll use the state inside of the match controller, and we'll use the started variable. So if the game has processed this input or the match has not even started yet, then we don't want to actually count the player's clicks because they're not in the middle of a match. So we'll use return to guarantee that the game has not processed the event and the match has started. Now the next thing that we want to do is determine if the player has clicked or tapped their screen. We can do this by comparing a property of the input object, and the property that we're going to use is the user input type. And we want to check if that is a specific user input type, which is called touch. Then we can actually go ahead and just copy this condition and say or, and now we want to check if the user input type is a mouse button 1. So if the user input type is touch or mouse button 1, which is click or touch, then we're going to go ahead and actually call the tap function that we just created. And there we go. That's actually all that we're going to do inside of where we connect to the input began event. And now we're calling the tap function. Now, there's one more sort of prerequisite function that we need to create. So let's go all the way down towards the bottom of our script. We'll create this brand new function, again, a part of the local table. And we're going to call this setup opponent viewport. And it'll have one parameter, which is going to be the opponent, which is a string, just like that. Now, if you're unfamiliar with how viewport frames actually work, basically you can store a model and a camera inside of a viewport frame to easily sort of display a model inside of your 2D GUI. Now, the model that we store inside of the viewport frame is going to change every time, as it's going to change with the opponent. So the first thing that we want to do is check if a model already exists inside of the viewport frame, and if it does, we need to clean that out, so we're going to go ahead and destroy it. So we'll create a variable called oldModel, and inside of the opponent frame, we have a viewport frame, and we'll actually use the findFirstChild of class method on it, and we're going to look for any model stored inside of there. And again, if we do find that, then we're going to go ahead and actually destroy it. Now that we've cleared the old model out, let's go ahead and get the new model. To get the new model, we want to go inside of the workspace, inside of the NPCs folder, and then we'll index that with the opponent argument that we got passed to this. Once we get the model, we do want to clone it, so we'll go ahead and use the clone method on it. And since we've cloned it, the next thing that we want to do is parent it to the viewport frame. So we're going to say model.parent equals opponent.viewport frame. Next, we got to set up the camera. So we'll create a variable called camera. And first we want to check if a camera already exists inside of here. Now, I'm not going to lie, I'm tired of typing out opponent.viewport frame. So the first variable that we're actually going to create inside of here is going to be called viewport frame, and we'll set that equal to opponent.viewport frame. Now let's go ahead and update all of our usages of opponent.viewport frame right there and right there. And then let's get back to the camera. So inside of the viewport frame, we again want to use findFirstChild of class, and this time we want to look for a camera. If we actually don't find a camera inside of there, then we want to add one to it. So we're going to say camera equals instance.new. We'll create a brand new camera, and we'll also parent it to the viewport frame. Now that we've parented it to the viewport frame, we actually have to update a property of the viewport frame called current camera, and we want to set that equal to this camera that we just created. So now that we know that we actually have gotten a camera, we have to consider how we want the model to be displayed in the viewport. And how we want it to be displayed is we basically want to take a picture of the model's head. So let's create a variable for the head position. And we can get this because inside of the model, there is the head part. And from the head part, we of course can get the position. Next, we'll create a variable called target position. And this is where we want to move the camera to. Now, we'll use the head position for this, and we'll subtract a vector 3 from this. And basically, we just want to subtract 2 from the z-axis, which will basically move the camera, which is looking at the model, in front of the model. So that's kind of how we're taking a picture of its head. Now that we've calculated the target position, let's go ahead and update the C-frame of the camera. So we'll create a brand new C-frame, and for the first argument, we'll pass through target position, And for the second one, we'll pass through head position. And now that's all that we have to do inside of this function. Okay, we're done with creating this function. And again, we're not going to use this one yet. We have one more prerequisite function to create. The function is, of course, going to be a part of the local table, and we're going to call this display countdown. And it's not going to have any parameters. This function is obviously going to be called right before the match starts for the player. So with this function, we want to update the status text label in order to visually display an actual countdown. Now, the first thing that we want to do with the status text label is we actually want to update its text color 3, and we'll set this to a color 3.fromRGB, and we're actually going to set this to white. So we're going to say 255, 255, 255. The reason that we're doing that is because we also use the status text label when we display the results of the match to the player. And inside of there, we modify the text color 3 as well. So that's why we change it back to white whenever we use it inside of this function. Now that we've reverted its color, let's go ahead and actually make it visible. So we'll set the visible property of it to true. Now the countdown is going to count down from 3 all the way down to 1. And each time the number changes, we're going to perform a little animation on it. So we're going to tween it, and we're basically going to make it a lot smaller. And then when we update the number again, we'll reset it back to its original size and then animate it by making it smaller. So we're going to create a variable called original size, which is going to be equal to the text size property of the status text label. Then we'll create a variable called countdown, which we're going to set equal to 3. We'll then create a while loop, and the condition here is that the countdown variable is greater than 0. Now, of course, when we're in the while loop, we're going to use a task.wait, and we want to wait 1 second each time. Then the first thing that we want to do inside of here is actually update the text of the status text label, and we're going to set that to the countdown. Then we'll update the text size of it to be 100, and now it's actually being displayed to the player. So then we want to perform a tween on it to make it smaller. So we'll create a variable called tweeninfo, of course tweeninfo.new. We want this to take up about half a second, and for the easing style, we're going to use linear. Then we'll create our tween props table, and the property that we want to modify is going to be text size, and we want to set that to 0. Then let's go ahead and actually create our tween. So we'll say tween service :create. We want to tween the status text label. Then we'll pass through the tween info and the tween props as well. And now that we've created it, let's of course go ahead and play it. And then right before task.wait, each time we go through this loop, we of course want to subtract 1 from the countdown. So we go from 3, 2 to 1, and then the countdown is finished. Now, after the while loop finishes, and we want to go ahead and set the text size property of the status text label back to its original size. In addition to that, we're also going to update the text of the status text label to say go! Then we'll go ahead and wait 1 second, and after that time is up, we'll go ahead and hide the status text label. And that's all that we're going to do inside of this function to display the countdown. So now that we've pretty much created all of the puzzle pieces for our puzzle, it's time to start putting everything together. Looking back at our onStart function, we can see that our first event here is the match countdown function. So let's go ahead and start off with creating a function for that. Beneath the onStart function, we're going to create another function, which again is going to be a part of the local table, and we're going to call this setupMatch, and it's going to have a single parameter, which is going to be opponent, and of course that'll be a string. Now, like I explained earlier, some of the functions that we use inside of here are going to begin with a task.wait0 because of how they're called and how our state actually works. So first we'll start off by saying task.wait0. After that, the first thing that we're going to want to do inside of here is actually set up the opponent's viewport frame. So we're going to say local, set up opponent viewport, and then we'll go ahead and pass through the opponent. Now that we've set up the opponent viewport frame, we need to set up a couple of other things for the opponent as well, like displaying their name and the amount of power that they have. Now, to determine the amount of power that they have, we're actually going to have to use the opponent's config for that. So let's go ahead and create a variable called opponent config. And to get that, we're going to say opponent's config.config, and then we'll index this variable with the opponent's name. Now that we have the opponent's config, we're going to go inside of the opponent frame, and we have a text label inside of there called player name. We want to set the text of this equal to the opponent's name. And now, additionally, inside of the opponent frame, we also have a text label called power, and we want to set the text of that equal to the opponent's power. So we'll say opponent config.power. Now we're displaying everything that we need to for the opponent. We also need to display our own information for ourselves. Now, the first thing that we're going to do is get the headshot picture of our avatar so that we can update our image label. So first, we'll go ahead and create a variable called self-thumbnail. And to get this headshot of our avatar, we're going to use the player service because it has a method called getUserThumbnailAsync. Now, for the first argument of this function, we need to pass through the player's user ID. For the second argument, we need to specify the thumbnail type that we want to receive. So we'll say enum.thumbnailType, and we want to get the headshot. Then for the final argument, we need to specify the thumbnail size. So we'll say enum.thumbnailSize, and the size that we're going to get is actually 420 by 420. Now let's go ahead and begin updating a bunch of different things inside of our self frame. So the first thing that we'll update is actually our player name. And of course, what do we want to set that to? Well, we will set it to our actual player's name. Then, just like the opponent, we also want to update the text of the power text label. And how do we get the player's power? Well, we say player.leaderstats.power.value. Then we want to update the image label inside of the self frame as well to display our own headshot. Now the image label inside of this frame is called headshot, and we want to set the image property of it. And we'll go ahead and set that to the self thumbnail variable that we just created. Now that we've updated basically everything that we're going to display to the player, the next thing that we want to do is basically reset the frame's position to where it should be positioned, because remember, once the match is over, we're going to perform a small animation and actually tween this and bring its position downwards so that it looks like it falls off the screen. So when we display this to the player again, we want to reset its position to where it originally was, where the player can actually view it. And in order to do that, we're going to say frame.position equals, and then we'll use our frame positions constant, and we want to use visible here. Now that we've repositioned it, we also want to go ahead and make it visible so that the player can actually see it. So now the player can actually see the progress bar frame, along with everything else that's included inside of it. The next thing that we want to do is actually update the progress bar. And we can do this by just calling the update progress bar function. Now, another thing that we want to do is begin displaying the countdown. So we'll go ahead and call the display countdown function as well. And there's one more final thing that we need to do. It's a very small detail, but with the title text label, we actually want to set the visibility of it to false when this function is called, and we'll actually make the title text label visible when the match actually begins and the player can begin tapping. Remember, the title text label is actually that text label which displays the player's clicks per second and tells them to actually begin tapping. So that's why we're not going to begin displaying it until after the countdown has finished and the player can actually begin tapping. With that being said, that's all that we're going to do inside of this function. So let's go ahead and hook it up to the networking, and we'll go ahead and connect that to the match countdown function. So we'll go ahead and say local setup match, just like that. Then we have the match start remote event. So below our setup match function, let's go ahead and create another one. This will be called start match, and it's not going to have any parameters. Now this function is actually going to be incredibly simple. The first thing that we want to do when we start the match is we're actually going to update the progress bar. In addition to that, we're going to go ahead and begin the CPS loop, which, if you forgot what the CPS loop does, it just constantly updates the title text label to display the amount of times that the player is clicking per second. And along with that, we also want to make the title text label actually visible so that the player can see it. Like I said, this function is extremely simple. That's all that we're going to do inside of here. So we're finished creating that. Let's go ahead and hook that up to the networking. So we'll hook this up to the match start remote event, and we'll say start match. And now, last but not least, we have the match end remote event. So we'll go ahead and create a function for that. We'll call that end match, and it will actually have a single parameter, which is going to be did win, and that'll be a boolean. Now again, this function is going to start off by using a task.wait 0. And the first thing that we want to do inside of here is actually display if the player has won or not. So we can use the display status function, and we'll pass through did win to that function as well. Now, since the match is over, we want to go ahead and perform that little animation on the primary frame and move that downwards off the screen so that the player no longer sees it. So let's go ahead and set this tween up. We'll go ahead and create a variable for the tween info. Of course, we'll say tweeninfo.new. We're going to wait 0.25 seconds. We'll make this take about 1/4 of a second. And for the easing style, we're going to go ahead and use linear. Then let's go ahead and create the tween props table. Of course, the property that we want to modify is the position. And what are we going to set that to? Well, we'll use the frame positions constant and we'll use hidden. Now we can go ahead and create the tween. So we'll say tween service :create. And what do we want to modify? Well, we want to modify the frame. Then we can just pass through the tween info and the tween props as well. And now that we've created that tween, let's go ahead and use it. So we'll say tween play. Now, there's one more thing that we want to do with this, and more specifically, we want to do something when this tween has finished playing. So of course, we'll go ahead and connect an anonymous function to the completed event. And inside of here, what we're going to do is make the frame no longer visible. So we'll set that to false. In addition to that, we're also going to actually reset the progress that the progress bar displays. So to do this, we're going to say progress.size. And of course, we're going to use a udim2 for this. We'll use from scale. And for the x, we're going to say 0.5. And for the y, we'll say 1. So now we've reset the size of the progress bar, and that's all that we're going to do with this function as well. So let's go ahead and hook this up to the networking. We'll hook this up to the match end event. So we'll say local.endMatch, just like that. With all of that being said, we have completely finished every single thing that we actually need to do, so we can go into our game and begin testing this out. Okay, one quick thing to fix. Obviously, make sure that you spelled all of the properties right. So we spelled position incorrectly there. Make sure you actually spell the word position correctly. Okay, one more mistake. Man, I really let the organizational part of my brain take over here, and I made a slight mistake. I really should have just followed my previous code that I've written down before. Anyway, we need to change when we actually set the visibility of the title text label to false, and we need to do that before we call the display countdown function. The reason being is because the display countdown uses a while loop, and this function will effectively stall for about 3 seconds at least. So if we make the title text label not visible after we call the display countdown function, this will actually not run for about 3 seconds later, and that's not what we want at all. Now, the reason that my brain did this is because this organization just looks a lot worse than this, in my opinion. So my organizational side of my brain kind of took over, and that's why we did it that way. Anyway, we put it back like this, and we should be good to go. Sorry for these little mistakes, but at least they are very easy to fix. Inside of our match UI, we have our click frame right here, and we want to make sure that the visibility is actually set to true. The alternative here is that we could, of course, add to our script to actually set the click frame to be visible, but it's perfectly fine to keep this visible at all times. Now, in addition to that, we can also set the size to 0000 so that our players don't actually see it at all. Alternatively, if you wanted to, you could set the position of it by default off the screen so that the players don't see it either. There's just a couple of different ways that you can actually handle this. And one more thing to actually clear up, we want to update the opponent's config. So inside the replicate storage, inside the configs folder, we have the opponent's config. When I scripted this beforehand, I actually had an if statement here that we did not include inside of this video because I actually thought it was completely unnecessary. But I should have known better. I feel like that's one assumption that you need to make as a programmer is that there's a possibility that something is always nil. So basically, to tell you how this error actually occurs, at the end of the match, when we call the update progress bar function, we actually pass an opponent to this function from the state of the match. The thing is, though, is that once the match is actually finished, we clear the state out, so there is no real opponent in that state any longer. And since there is no valid opponent that would be inside of our opponent's config, we receive an error here. So the simplest way to solve this is by saying if not opponent config, then, and then we'll just simply return the number 0. And that's just a quick, simple, and easy way to clear up this error. So now, hopping into our game, we're going to go ahead and test this out with John. We'll get into a match, we see a countdown starts. Once the countdown finishes, we can see that that text label actually appears. When we click on the screen, we can see the actual clicking animation, and we can see that our screen zooms in as well with each click. With each click, up to a specific limit though, because remember, we did actually set a limit to that. And also, if you're looking at the sort of image, or realistically, that's the viewport of our opponent on the left, and you're looking at your headshot on the right, they of course might look the same, but that's just because we're literally using my own avatar right here. So of course they would look the same. If you just change your model with any different one, you should be able to see the clear and distinct difference. Anyway, let's go ahead and win this match real quick. And once we win, we can see that I have won, and the camera fades back to where it originally was, and there we go. I'm a winner of that match. Now let's go ahead and fight him once again, and once we fight him again, we can see that this is all actually working as it should be. So I'll go ahead and just let John win this match because, you know, I'm a nice person, and we also want to make sure that everything works. We can see that you lost, that fades out, and now that's all good to go. So yeah, everything does actually seem to be working here exactly as it should be. So with all that being said, that's going to be it for this video. If you did enjoy and you have made it this far in the video, please smash the like button and leave a comment letting me know if this did work for you. It's really common for people to finish my videos and then not leave a comment saying that it worked, whereas if somebody encounters an issue, they will leave a comment saying that the video didn't work for them. So when other people see your comment saying that it did actually work, it'll hopefully help them realize that they may have made a mistake and the tutorial does actually work, they just have to follow it correctly. Along with that, if you want to support me, feel free to visit my Patreon or monster.dev, link down below in the description to both of those, to gain access to all the scripts that we made in today's episode, as well as other games, and tons of other resources that can easily help you create your next Roblox game. And with that being said, I hope that you have a great day, and I'll see you guys in the next video.